Welcome and good morning to the second day of the FCC's Open RAN Showcase. After an excellent day of presentations yesterday, I'm excited to hear from our presenters today. I'm Justin Fall, Acting Associate Bureau Chief for the Wireline Competition Bureau. And this showcase is especially relevant today because we are featuring presentations for anyone interested in acquiring O-RAN compliant equipment and services. The vendors presenting today all have products that are ready for deployment now, or will be ready for deployment no later than January 1st, 2022, which could be deployed by providers who may be participating in the Secure and Trusted Communications Networks Reimbursement Program. Starting us off today, we have a special guest. We will be hearing opening remarks from Evelyn Romali, Acting Assistant Secretary of Commerce for Communications and Information and Acting NTIA Administrator. Acting Administrator Romali is traveling today, but has recorded her welcoming remarks, which will now play.
Thank you. It's great to be with you today. I want to thank the FCC and the chairwoman for hosting this event and for inviting me to join you. As you know, NTIA works very closely with the FCC, and we've been deepening our commitment to collaboration over the last several months, especially as we take on the complex challenges of expanding broadband to all Americans, freeing up spectrum for commercial use, and incentivizing security in our next generation networks. I am very appreciative of their collaborative spirit, and I'm encouraged by our joint efforts to promote Open RAN networks. The major lesson so far in the 5G era is that collaboration and trust are more important than ever. All of our goals, from promoting innovation to increasing security, work best within strong partnerships with industry and across government. The Biden administration views 5G security as a high priority. Americans need to be able to trust that 5G equipment and software will not introduce risks that threaten privacy, national security, or human rights. At NTIA, the National Strategy to Secure 5G Implementation Plan guides our work to ensure the development and deployment of secure 5G networks. The National Strategy to Secure 5G is built around four main pillars. First, facilitate domestic 5G rollout. Second, assess risks to and identify core security principles of 5G infrastructure. Third, address risks to United States economic and national security during development and deployment of 5G infrastructure worldwide. And fourth, promote responsible global development and deployment of 5G. A common theme throughout the national strategy and its implementation plan, and a key area where NTIA is focused, is the promotion of vendor diversity and open architectures. The US government recognizes that many network operators in the United States and across the world struggle when selecting vendors to develop and deploy 5G and earlier generation wireless networks. They seek providers they can trust, rapid and best-in-class innovation, and price competitiveness. And they want access to a resilient supply chain to ensure the reliability and agility of their networks into the future, regardless of situation or circumstance. Long innovation cycles are no longer sufficient. Networks must have the ability to advance and evolve rapidly to drive and meet the demands of our digital economy. A digital economy that is the best in the world and critical to our national security. One of the surest routes to a more secure supply chain is developing a more robust 5G commercial ecosystem in the United States. We need to ensure that we are working to support both the use cases and demand for 5G technologies that will in turn drive their development and adoption, as well as the market incentives that allow our companies to thrive and compete at home and abroad. Open and interoperable approaches offer the promise of a future with a wider variety of hardware and software vendors and the ability for operators to disaggregate their networks between them using open interfaces. The US government therefore fully supports industry's development of open interoperable networks while recognizing the importance of maintaining a full suite of solutions offered by incumbent trusted vendors. And while this effort can and should be industry-led, governments can help to promote open networks and foster the conditions for their successful deployment and growth. The development and deployment of open networks would allow operators to select hardware from a range of vendors to meet their specific needs. It would also give them the flexibility to upgrade their network in a more gradual manner, as opposed to facing the full capital expense of a network upgrade at one time. The increased competition between vendors could also drive down prices. This is a worldwide trend. Countries like Japan and the United Kingdom have already invested in research labs, test beds, and policy tools to promote open architecture networks. As a result, international engagement in this area is a high priority, and NTIA's international team continues to engage on open and interoperable networks in a range of multilateral venues. We are also working with our interagency colleagues to engage bilaterally with a range of partners to discuss ways to remove barriers for new entrants to the market and incentivize technology investment in vendor diversity enabling technologies. We are actively engaging with industry and global counterparts to advance progress toward a set of high-level principles on this issue. NTIA has also formed a 5G vendor diversity working group to coordinate US government efforts to reduce barriers for new market entrants, increase the diversity of vendors offering 5G network equipment and services, and promote the development of open interoperable networks. The group is working to achieve these objectives through information sharing, messaging development, private sector engagement, and outreach to foreign governments and stakeholders. I would also like to highlight that NTIA's Institute for Telecommunications Sciences in Boulder, Colorado, is exploring the potential of a 5G challenge in collaboration with the Department of Defense. The idea would be to accelerate open interface adoption and the development of interoperable 5G components with DoD-grade security from a variety of trusted vendors. We hope to share more about this soon. To be clear, we are not looking to mandate what technology any operator should use or to have governments distort the market. We are instead looking to foster cooperation with the private sector and other like-minded governments on research and development, trials, test beds, and capacity building to promote increased choice and more innovation, including through Open RAN. We've done extensive outreach to stakeholders to inform our approach, but we would still welcome additional thoughts on what our industry partners think should be included and any possible next steps. NTIA thrives on partnerships and collaboration, and we are always looking for new avenues to make progress on our shared goals. Thank you for having me today. Congratulations to the FCC and all the vendors, and enjoy this showcase.
Thank you very much, Acting Administrator Romali. The remainder of the showcase will be focused on hearing from vendors featuring mobile operator networks, and system integrators, and then end-to-end Open RAN solutions. Following our first two sessions, we'll feature a lunchtime fireside chat between MITRE and Vodafone about Vodafone's Open RAN deployments and their lessons learned. We'll finish with a session in the afternoon featuring additional end-to-end Open RAN solutions and brief closing remarks. Before we start, I want to remind everyone about a few important points about the showcase. First, the showcase and participation by any company or organization is not endorsed by the FCC or its leadership of any product or service discussed at the event. In addition, as a courtesy to all participants, and to make sure we stay on schedule, or at least as close as we can, we'll be limiting each participant to their allocated time slot. We'll let you know when you have 5 minutes left, and you should feel free to ask to skip slides if you're running short on time. Finally, as a housekeeping note, I would ask that you keep your video off and your microphone muted until you're presenting. Thank you. So let's move to session 4. Session 4 features presentations from mobile network operators and system integrators. We're going to hear presentations from Dell Technologies and IBM. First up is Sarvesh Sarma, Network Architect, Americas, for Dell Technologies. Sarvesh, I'll throw it to you.
Thanks, Justin. Good morning. Let me begin by a huge shout out to the wonderful team at FCC that have made this event possible. Also, my sincere thanks to all of you for making time to participate in it. I truly believe that exposure to this innovative and diverse ecosystem of suppliers will be very useful in your 5G related strategies and plans. Next slide. Next slide, Justin. With 5G becoming a reality, a key observation is that the end consumer of service is no longer just an individual, but instead an enterprise, a device, or an application. This trend is not limited to the urban or suburban areas, but is extending nationwide with use cases such as smart agriculture, smart cities, smart manufacturing, smart automotive, amongst others. The next slide outlines the target architecture associated with this paradigm, along with its opportunities and challenges. One slide back. Oh, okay. Sorry, I think we missed a slide in between, Jason. All right, no worries. In this new paradigm, the network architecture, which was traditionally static and based on functional hierarchy, must transform to become more dynamic and agile based on service consumption location, as well as service characteristics. This requires cloud-native operations with hybrid and multi-cloud environments to enable the monetization of digital services by bringing capabilities to the edge in order to nurture an innovative use case ecosystem. Why? Because this avails opportunities to tap into enterprise and IoT as the new growth engine for revenues in order to help the top line. Additionally, the ITization of the telco network with scaled automation leveraging AI/ML also helps with lowering of OpEx costs that helps the bottom line. This includes leveraging the hardware technology curve, simplified SKUs for spares and inventory, and elimination of vendor lock-in. Of course, these opportunities come with challenges such as access to an ecosystem of use cases, service validation, integration, access to enterprise sales channels, disparate platforms, the required upskilling of personnel, as well as upgrading of operational processes. Dell recognizes these challenges and has geared up to become your system integration and services partner by growing the telco expertise, especially in the area of O-RAN and 5G core. The next slide shows a typical disaggregation that is associated with evolving to a O-RAN architecture. Just in one slide back, please. It seems to be skipping slide. There we go. Now, I'm positive that most are familiar with the O-RAN architecture, so I'm not going to drain this slide in the interest of time. The point is that this architecture brings in the promise of service differentiation and lower TCO with greater operator control. However, a key requirement is a strong SI partner that can also help secure the telco supply chain. This is where Dell differentiates, as is illustrated in the next slide. Telco transformation requires a combination of IT transformation, network transformation, and a robust services portfolio. We have been delivering IT transformation for decades, which most recently meant modernizing IT services through a robust hybrid cloud approach. This approach enables you to opportunistically leverage private and public clouds via a common infrastructure management and abstraction layer. The requirement is to establish a cloud-native application platform with a variety of Kubernetes distributions. Our approach to telecom is to extend the same principles into building and managing a telecom network. We customize those principles to build a carrier-grade, disaggregated telecom infrastructure with platforms built on open, industry-standard hardware ecosystem that embraces a multi-vendor approach across servers, networking, storage, data protection, all the way to the radio itself. While we believe that our products stand on their own merits, we are committed to working with you to support the choices required by your business. We believe that with a well-managed and modern cloud-native platform in place, with O-RAN as the technology, the business can focus on their development efforts on delivering the differentiated services. Consequently, Dell Technologies has dedicated a co-creation services team whose sole job is to partner with CSPs to design, build, market, and sell telecom, SaaS, MEC, and private mobility services to the enterprise. All of this together is the Dell Technologies difference. To the telecom industry, we bring the engineering, the services, the supply chain, and the experience of helping thousands of customers digitally transform their business. As the next slide illustrates, we are walking the talk to establishing Dell in the Open RAN ecosystem. As was mentioned earlier in the opening remarks, we are in line with the 4 pillars of the NTIA 5G policy. We are committed to building and anchoring the industry's most robust open ISV ecosystem focused on the telecom industry. We partner broadly to serve differentiated solutions for OSS BSS, Converged Core, Services Edge, and Open RAN. The Open Telecom Ecosystem Lab, or OTEL, that we recently announced, brings together key players enabling true industry collaboration in order to provide support for activities that are critical to developing an ecosystem of open telecom solutions, such as certifications, development of open multi-vendor solutions, POCs to accelerate time to market and time to revenue, facilitation of collective innovation and integration, among others. The mission of OTEL is to accelerate and simplify the creation of an open and modern telecom ecosystem. Together, these curated hardware and software ecosystems give you the flexibility and choice you need with the confidence that they will interoperate, deliver the most value, and you will receive the support you require throughout their lifecycle. As shown in the next slide, it all begins with harmonized platforms. We understand that Open RAN offers the promise of choice and flexibility, but that comes with the complexities of integrating and deploying multi-vendor solutions. As we transition away from purpose-built hardware and software designed to work together as one appliance, we need to focus on making open technologies from multiple vendors as reliable as the purpose-built solutions they are replacing. Dell Technologies is the only partner in the position to bring virtually any ecosystem together and have the resources available to provide a fully customizable turnkey solution. And this includes everything for the solution, such as hardened equipment that is fit to withstand extreme environmentals, providing a deterministic timing system, provide and/or partner with the highest performance equipment that includes industry-leading FPGAs, GPUs, and other high-performance infrastructure. Provide full automation of bare metal infrastructure that enables the zero-touch provisioning, and more importantly, mapping of the workload to the appropriate compute platform. As our next slide shows, a full suite of solutions is needed to leverage this. Our next-gen operations portfolio includes secure and automated on-prem hybrid cloud offerings with bare metal automation and advanced analytics that unlocks the full potential of cloud-native and microservice-based software frameworks. It will deliver the workload flexibility as well as benefits from real-time insights, innovation, operational agility across network services via AI ops and intent-driven operations. Our Converged Core offering delivers the 5G core transition by converging VMs and containers across a common and open cloud-native telco cloud platform with a validated multi-tenancy ecosystem as well as flexible delivery models. The goal is to provide this integrated solutions with partners, complemented by Dell's advanced services, as well as a as-a-service consumption model. In the services edge, the volume of edge locations, the multi-tenant offerings, and the distributed management creates complexity. From core to on-premise, we enable horizontal enterprise service platforms with optimal server variants and networking to facilitate innovative in-network and enterprise use cases. Similar to our converged core offering, our integrated solutions with partners are complemented with Dell Advanced Services here too, as well as a service consumption model. Now, as discussed before, the disaggregation brought by O-RAN, multi-vendor system integration is expected to be complex. The industry is asking for recommendations on chipsets, on NICs, on integration with new platforms. Many vRAN software vendors, particularly the smaller ISVs, lack the integration resources at scale. In this area, Dell is de-risking deployments via a systems approach to a validated set of solutions based on best-of-breed, harmonized CU/DU platforms. Our embrace of partners, as opposed to an all in-house solution approach, is the key attribute needed by any system integrator. The next slide shows how strong our engagement is in this area. Given that the ecosystem is at the heart of an Open RAN, and Dell is uniquely positioned in the market to bring that disruptive ecosystem into play, there are multiple standards and policy organizations, including ORAN, TIP, as well as the Open RAN Policy Coalition. And our CTO community is participating in their work groups to stay abreast on all the common requirements for ORAN. There are many disruptors in the industry, such as Altiostar, Mavenir, Parallel, including companies like Ruckus, GMA, and you'll hear from all of them today, or have heard from them yesterday. These companies are trying to offer a strong alternative to the traditional network equipment providers. Dell is partnering with many of these disruptors to bring to market the Open RAN solutions. However, we also have very close partnerships with the traditional RAN vendors, who are also a very crucial part of the ecosystem. On the supply side, accelerators, chipsets, among others, play a critical role in Open RAN, given the stringent performance requirements. The demanding CU and DU requirements require the performance, efficiency gaps, and price points to be competitive, and companies such as Intel, NVIDIA, and others are critical to making this happen. We understand the importance of the ecosystem and are investing heavily in this area to ensure operators have the choices to pick and choose the technology vendor across the entire Open RAN architecture, as is evidenced by our OTEL announcement and the engagements shown on the next slide. I'm not going to drain this slide, but it suffices to say that we have been active with several of our CSP operator partners in co-innovating and collaborating on ORAN and 5G core platforms and solutions. I will not drain the slide, but the logos and activities clearly establish the broad acceptance of Dell as a key ecosystem enabler and a systems integration partner. Of course, any full suite partner will have a strong services portfolio to match, as is shown in the next slide. At Dell, we are focused on outcome-based services with a full end-to-end program management. We will work with you on day zero services, such as deciding the location and topology of ORAN functions. Remember, in the earlier slide, we saw how the functions are disaggregated almost geographically and moving closer to the edge. So the design and the selection of the appropriate platform has to take into account the latency, the performance, and the coverage needs. More importantly, we have to ensure interoperability and integration end-to-end from core to access, given the broad disaggregation. and we will help you with all of that. But we don't stop at that. Our day one services are geared towards speed of deployment and provisioning. We have the unique capability to factory integrate, rack, stack, and ship platforms that arrive on site and just require power and connectivity. Not many people can effectively deliver on this promise. Beyond that, we offer day two services that include operational automation, network reliability engineering, service reliability engineering, and AI ops to drive the cost out of operations while meeting your SLAs. In conclusion, next slide, please. In conclusion, I hope I was able to share with you a broad, high-level view of our commitment and capabilities in our desire to becoming the bedrock of the modern open telecom ecosystem. We look forward to a more detailed session with you to dive deeper into how we can work together with you on your transformation journey as you look at deploying O-RAN technologies in your network. Once again, a shout out to the FCC team and a huge thank you for all of you guys for making time to participate on this panel. Thank you.
Thank you very much, Sarvesh. We'll now hear from Marissa Viveros, Vice President, Strategy and Offerings, Telecom, Media, and Entertainment Industry from IBM. Marissa, it's yours. Thanks.
Great. Thank you, Justin, and thank you to the FCC team for organizing this event. I echo many of the thoughts that my colleague from Dell had. So in this presentation, I will try to give you a view of what IBM participation is in this domain and how we're working with clients and telcos around the world as it relates to not only Open RAN, but also the overall network virtualization, as well as the transition into 5G and other edge computing. I will begin by saying IBM has a long history in services. Beyond, probably you all know technology from IBM. Beyond technology, we have done services for many years, starting with the census. When U.S. government did the first census across the U.S., we began building the technology there. We followed by participating when the U.S. put the man on the moon. And again, it was IBM services that was behind also in some of the key deliverables to achieve that. Therefore, we feel very proud and confident that we can participate in the Open RAN journey with our clients, as well with telco clients, as well as with enterprise clients. So, Justin, if we can go to the next slide, please. I will start by sharing with you what IBM presence is within the telecommunication market. And in fact, we bring many of our professional services within that. We are serving more than 80% of the telcos on the IT infrastructure around the world, as well as their operation management. We are delivering today AI capabilities that allow our clients to be more automated, offer great experience to the end users, as well as integrating AI throughout everything we do within the telecom network, as well as the enterprise. So automation and AI become significant bedrocks within this environment. We also have tremendous presence with our Red Hat acquisition across more than 200 telcos around the world. And I must say, I feel very proud that we have embraced open source, open standards, and open technologies since day one. So as it relates to network and Open RAN, we have had, we are founding members of the LF networking, where ONAP and other technologies are coming out of there and placing those within the automation of the network. We are among the top 10 contributors within that, as well as part of the governance system. With O-RAN Alliance, we have been working on machine learning and AI, contributing to some of the work groups that are going on in order to improve the automation on how O-RAN gets delivered for our telcos and how it gets integrated throughout the network. Also members of TIP, the Telecom Infra Project, which is an organization led by the telcos, and also making contribution there. And finally, working with my colleagues in government relations, as well as the US government, and many other companies around the Open RAN policy coalition. So that's just the presence that IBM has in this market and how we are delivering to our clients within this domain. We announced back in November the IBM Cloud for Telecommunications, which allows really to lower the cost of ownership to our clients on how they deploy the network function and services as they move forward in this journey of moving the networks into the cloud. I will not delve into architectures because many of my colleagues probably here have done that, but I will try to focus more on what we do from a system integrator point of view, so you get an appreciation of why it's needed and how it works, just like my dear colleague said, how we work with the ecosystem in order to achieve that. When we go from a fully integrated network into a fully disaggregated network, working in that ecosystem becomes paramount. So if we move to the next slide, these are some of the key areas where IBM is participating. First of all, let me just talk a little bit about Red Hat and OpenShift and OpenStack as the core platform. You can think about the operating system of the key products, whether it is your 5G core, your enhanced EPC, your IMS, or your Open RAN. All of those need an operating system, a platform in which to run those applications. In this case, we have positioned OpenShift, and in fact, we're working with a number of partners that are also part of this event, working with them in enabling their technology on OpenShift, starting with one of our key partners, which is AltoStar. On the software side, I mentioned already a couple of times automation. We are delivering a multi-domain orchestration. If you can think about it, we are orchestrating and facilitating, doing upgrades, making sure that the resources are there from a point of view of the hardware resources, the virtualized resources, and then the network functions as well as the service. So different layers, they all require significant automation and understanding of what's going on in the different pieces of the network and where the services are in order to achieve that. Furthermore, we also deliver the software based on AI and machine learning, doing predictive analytics and predictive time series analysis to understand how we can operate the network. So again, we offer capabilities on the software side that can do that. Furthermore, you may have seen later on the acquisition of Turbonomics in the recent months in SEV1, which is a key capability that will also contribute in that automation of the network and automation of the processes that are going on. On system integration, I will go deeper into what are the different components and building blocks that requires for an Open RAN solution. But I'd like to highlight services around the manual layer, the orchestration and the management orchestration of the network, managing continuous integration and continuous development and the DevSoft capabilities that we help our clients now take those processes that before they were all hardware-based oriented, now taking them and getting them software and being able to deploy those within the network. And of course, service assurance that I already spoke about. We operate today what we call the VNF or CNF factory. So that means we are constantly onboarding our clients' technology and our partners' technology in order to make them more efficient, new releases, new capabilities that needs to go on. We do the pre-integration and pre-testing in our lab. Finally, we work with a number of partners, including Kyndryl, one of the companies that is an offset of offspring of IBM. We work with partners in terms of infrastructure services in order to bring the compute, the storage, and the network all in one solution. And like all of my other colleagues said, we also focus heavily, and this is just a sample of the 44 and companies that we have in our ecosystem today, and that keeps growing every day with technologies, with new entrants, new companies that are producing very innovative technologies, and then also with global system integrators. So these are some of the capabilities that we bring to bear into a network transformation, that it is the core of the network as well as the access layer of the network. So it's not just Open RAN. You also need to have the core of the network deployed. So your 5G core is fundamental in order to really realize and bring to life the full network. If we go to the next slide, these are some of, so I'm going to double click on the professional services. So let's start with, and these are the key building blocks that are part of a solution. We start with governance. Maybe sometime when we are doing a pilot or a POC, governance may be overlooked. But when you are doing a massive deployment, governance becomes very important from the point of view of the stakeholders, of the engineers, and actually the execution of those projects. Having that governance in maintaining the communication and solid processes to bring all of that together with all of the partners that now are part of this disaggregated network, the governance becomes critical. Along with that, organization and process change management. As you all know, we can deploy something, whether it's a piece of software or hardware, but that needs maintenance. That needs new releases. And in the age of the cloud, those software releases may come every week or every month, as opposed to in the prior times, those releases may be every year or every 6 months. Now the changes will be daily or weekly or monthly. Therefore, change management process from the point of view of technology, processes, and people needs to be very, very strong. And that's what IBM has excelled for the past 50 years in doing that type of complex projects and complex deployment, in bringing also that process change management. Now, as it relates to technology, the RAN Spectrum Advisory Service, that's something that we offer. There are many spectrum bandwidths and areas that clients can use. Within that, we also bring the network build services, whether it is, I already spoke about the core and the edge, building the sites and integrating those, doing site service for RAN and making sure where those cell sites are going to be positioned, whether it is the metro area or the other less accessible areas, where those RANs are going to be positioned to get maximum benefit of all of the investment. RAN site modernization. Some of our clients are using their 4G, their LTE site in order to modernize now to 5G. Of course, capacity management, RAN optimization services, and RAN OpEx management services become critical in order to realize in a most cost-effective manner a solution, as well as risk avoidance, so minimizing risk and ensuring that our clients get deliver to the services that they need to deliver, as opposed to be worrying about technology. And of course, the partner ecosystem is part of, integral part. And I'm just naming 3 of our key partners in this area, but there are many others that are participating with us in different kinds of service, including emergency response systems for the government and others in other countries. If we move to the next slide, I'd like to highlight one of the projects that we already delivered in Latin America. That project was done right in the middle of COVID. So as you can imagine, we have to deal with importing technology and distributing that technology. This is in the area of Puerto Madryn in the south of Argentina, a very touristic area. Therefore, a very hungry population for high level and high bandwidth in low latency that 5G can offer. What we did here is with the customer is Telefonica. We co-created and co-designed a solution in a reference architecture that will be most useful to them, most useful to the area, and we customize areas in order to take advantage of the localities of all of the services that were done within the domain and taking consideration of the topology of the country and the region. Of course, we managed there from getting all the hardware, all the software, tuning that, deploying the services, making those tuning the services and making those services available to end users. So this is no longer a pilot. This is an actual implementation that is expanding within the next years. I would like to finish before we move on to the next slide. I must say we're working with a number of telecommunication companies across the world, but I will say also we're working with several enterprises that wants to do a hybrid deployment where they own some of the Open RAN solutions within their own premises, manufacturing sites, auto manufacturers, and other type of and in conjunction with telecommunication companies for the broadband and the backbone of the network. We are working in those hybrid environment also because Open RAN is also very, very interesting to the large enterprises as the one that IBM serves. On within this is beyond telecommunication company, but it's also enterprises as well as as we move into compute and connectivity within the next era, this becomes technology and connectivity and communication and compute becomes much more integrated as we move forward. So this is key to not just to deploy an Open RAN, but it's to deploy new services. Those could be enhanced supply chain management, and those could be AR, VR, getting drones to work. All of these new applications that we're seeing and we're experimenting with, some of our clients are already doing those in production. So let's move to the next slide. So before I end, I would like to finish with some critical success factors. And maybe a little bit of a kind of summarizing what I have said in the previous slide and the importance of a system integrator in order to get that governance correct, get the design authority. Sometimes the client will want to have the ownership of the architecture. Many times we do it in conjunction. The standard management. We have all talked about open ecosystem in this forum. Therefore, I will not delve more into that. But I think it's important, and I think I mentioned a couple of times, the lifecycle management of the solution. Deploying it once is no longer the choice. We need to deploy in a way that we can do continuous lifecycle management of the solution. Testing, change management, in the whole supply chain management of the technology, getting to locations where perhaps that are inaccessible, and we want to make these Open RAN solutions. So very bright future in the point of view of it is a collective work between many companies. It's really opening up in making, it's realizing, the next view of our market, which is really the connection of compute and connectivity much tighter together in order to provide better solutions with lower latency and higher bandwidth and higher speed. So with that, I would like to say with the next slide, thank you very much for inviting us to participate in this forum, and look forward at working with many of the colleagues and with the FCC and with other colleagues in the US government in this endeavor. So thank you so much.
Thank you very much, Marissa. As a reminder for everybody watching from home, we'll be posting the presentations and the contact information for all of our speakers on our website for the showcase. You'll be able to find that at fcc.gov/events, the page where you found this. It may take a day or two to get video of these presentations up, but that will be hosted as well and archived on our website. We hope interested providers who are watching these vendors' presentations will reach out and follow up with any questions that they may have offline. So our next presentations are scheduled to start at 10:20 for session 5. We'll take a few minute break to allow those presenters to get ready, and I'll pass the moderator duties to my colleague Brian Cruikshank in the Wireline Competition Bureau. Thank you, and we'll see you in a couple minutes for session 5.
Welcome back to day 2 of the FCC's Open RAN Showcase. My name is Brian Cruikshank, Attorney Advisor in the Wireline Competition Bureau, and I will be guiding us through the next session, session 5, which features presentations by vendors who offer end-to-end Open RAN solutions. Here are the vendors we will now hear from. Abel Mayal, the Senior Vice President of Technology and Marketing at Airspan, Anil Bhandari, Vice President of Product Management at Altiostar, Matt Molester, Senior Vice President in the Office of the CTO at CommScope, Stephen Bai, Executive Vice President at Dish, Ishwar Parukar, Chief Technology Officer at Amazon Web Services, and Todd Landry, Vice President and Product of Market Strategy at JMA Wireless. For these vendors, the sessions will be 20 minutes long, but I'll provide a 5-minute warning. Please take it away, Abel.
Well, good morning, everyone. Thank you very much for being here. I'm very pleased to be presenting at FCC, and thank you, FCC, for this opportunity to present our vision and our portfolio on Open RAN and 5G. I am Abel Mayal. I am the SVP of Technology and Marketing at Airspan. Airspan is an American company. We have our headquarters in Boca Raton in Florida, and we also have a nice office with a lot of R&D going on in Santa Clara, California. We have been in this industry for more than 20 years, and our main goal has been always been to disrupt the RAN market by breaking the status quo of traditional vendors and the way they deploy the networks. And we have done that with our full end-to-end RAN solution, previously in 4G, and now moving towards 5G Open RAN. And for this session, we have seen, major 3 trends or markets that are driving our Open RAN portfolio. And we would like to present these 3 trends and how they link nicely with our Open RAN portfolio. So if we can go to the next slide, please. So these are the 3 main trends that we have seen. Basically, there are mobile network operators, private networks, and CBRS. Let's start with mobile network operators. So if you move to the next slide and to the following one, please. Excellent, thank you. So, as you can see, we have been, as I mentioned before, 20 years in the industry. We have shipped around 1 million radios already to more than 1,000 customers in 100 countries. One of the major countries, one of the major customers was Sprint before they merged with T-Mo. I think we deployed around nearly 400,000 radios, which is a large number of radios to be deployed. Also, for example, GeoReliance, who is one of the disruptive operator in India. They have only 2 vendors, Samsung and us, and we have hundreds of thousands of radios deployed. So you can see that the level of scalability that we have. But the important message here is about the new Open RAN products from our side, our 5G products. And we can see that, for example, we are already present in the first fully cloud and virtualized Open RAN and commercial networking in the world, that is Rakuten. So if we move to the next slide, please. Thank you. So we are a big part of this network. We are the unique vendor providing the 4G and the 5G radios. We have deployed tens of thousands of them, and the target is to go to more than 40,000 this year. And of course, the first message is that we can scale again in 5G Open RAN, but also answering a question that I get many times: when is going to be ready Open RAN and 5G? The answer is like, well, it has been already ready, since they launched last year, right? So you can go to Japan with your mobile phone, connect to Rakuten, and test, the high performance they have, gigabits per second, and the low latencies. Together, you can see all these reports, these public reports about the economics on the network, the reduction of costs thanks to the simplicity on deployment, but also the simplicity on maintenance, being a software-based network. But Rakuten is not the only one who is promoting Open RAN, even though they are the first commercial network. We have seen, the majority of operators around the world, the US, Europe, they have been very vocal on Open RAN and also their intentions. We have seen recently, for example, 5 major operators in Europe that released a document saying what are the priorities for them for Open RAN. So they're willing to go for Open RAN. And we're talking about Deutsche Telekom, Telecom Italia, Telefonica, Orange, Vodafone, all big names that they want to really go for Open RAN. Of course, here that what they see in Open RAN is 3 things. First of all, competition brings costs down, right? And there is this need of supply chain diversity, something that everyone, all MNOs are requesting. So that's why Open RAN is valuable. Also, this competition and also this disaggregation of software and hardware that reduces the cost. But very importantly, also is security, right? We have seen the issues that sometimes traditional vendors have with this black box approach of having proprietary hardware and software. The nice thing of Open RAN is you have these open interfaces that basically means that you have transparency there. So you can see what is the level of security that you want to apply. And also, most importantly, you can validate that the security is there. And make sure that you have this security. Also, you can trace where your data is going at all times, right? So you know how your data is moving. So this is why we see that MNOs are really, moving forward to Open RAN. And how MNOs are impacting our product line, I will say that there are 3 products that we see as priorities. First one is, of course, mobile operators that are interesting to extend the 5G coverage as the first priority. So that means that the first line of products from S-Band is, big macros, massive MIMO with high number of antennas, right? The second part that is going to be a key differentiator for the 5G networks is going to be what is called densification. Densification means that you need, since 5G uses high frequencies has lower coverage. So that means that you're going to have many coverage gaps when you deploy your 5G macro stations. So that means that you need a small cell radius in order to provide this lack of coverage, right? So this small cell radius is going to be the second priority for MNOs, and we have already launched a new portfolio of this small cell. And the third priority, we believe, is going to be indoor coverage, right? That is something that, for example, Rakuten has taken the 3 products already. So the macros for the coverage, they deployed the hotspots with our millimeter wave radios. And also now we are starting to deploy indoor using millimeter wave. So that would be the 3 products related with MNOs. Also, if we go to the next slide, please. Another thing that we have seen is the complexity of deploying 5G Open RAN. The industry has recognized that deployments with Open RAN are much more efficient, and we can show that with the list of awards we won this year for the 4th time in a row, the excellence in commercial deployment, and we are very proud of this award because we have won it before in 4G, but it's the first time we won it with 5G and Open RAN together with Qualcomm, who is our partner in technology for our radios in the Rakuten deployment. So we can see here that also the market gives recognition to these Open RAN deployments. So the message here is that Open RAN is here now. And for MNOs, we have the portfolio that is ready. So if we go to the next slide, we're going to move to the second trend that we see, that is private networks. So private networks, please, next slide. Thank you. So private networks is a booming market. We're very, very active there. And we have seen, the reason why private network is so booming is because 3 factors. First of all, dedicated frequencies for this market, right? For private networks. This is the case, for example, of CBRS, right? That provides easiness to get frequencies for networks or for counties to do their own network. So it's disrupting the way networks were given. So the second part is the 5G. 5G is a technology that is very much focused on public service, the standard commercial mobile phones, data and voice, but now it's very much focused 5G on the enterprise, right? With features like low latency, machine time of communications, all these sensors, network slicing. So all these features were requested and needed by the industry. So now it's possible with 5G. And the third trend is Open RAN. Open RAN, what it does is that is creating a simplicity on the deployment, but most importantly, is it accelerates innovation, right? With this new entity called RAN Intelligent Controller, that basically what it does is that open the radio to third-party companies to interact and improve the performance of the radios. So here in this slide, we have several activities that we are, that we're working on with several customers. CBRS is a big market for us. I mean, we have been very active in the previous years on 4G, now moving to 5G. Also, CBRS has been very, very helpful in COVID times, right? Because it gave us, and it boost and also speed up the creation of new networks, for example, in rural areas or where there was lack of connectivity, for example, for the education, right? So we have been very active working with these markets. On 5G Open RAN, we're moving now to more concrete specific verticals, for example, smart factories. We have another use case in the US, Gogo Networks, but this is quite a unique case. And basically, Gogo, what they try to do is to give internet connectivity into the airplanes, meaning that, I mean, their goal is to have office-like experience in the airplanes, and they do that using a 5G network on the ground. So we have Gogo has our 5G massive MIMO radios focusing on the sky, and we are covering the whole US and Canada, and they create connectivity 5G inside the planes. So this is very challenging, of course, because first of all, it goes beyond the limits of the standards of 3GPP. The speeds of the planes are much faster than the standard, and also, the altitude of the planes. But we are capable, with our experience on software, we're capable to tweak the software to meet even going beyond the standard. So this is a unique private network, huge in area of coverage, and we are very excited to be part of it. Then we have other use cases, for example, Millbrook in the UK related to connected vehicles, and other. I mean, there is a booming vertical that is Industry 4.0, and we're working with various system integrators in the US, in Europe, and also in the UK. The UK government is funding many of these projects, the CMS, and we are part of it in one of them. So what we have learned from these private networks is, first of all, innovation, right? We see that private networks are the ones who are driving the innovation. So that these are the industry that is pushing our software, right, to really have the features from the latest releases of the standards, from 3GPP, from Honor Alliance. So we are working with them in order to have all these features ready. Second thing that we have seen from this market is that they need different type of radios as the MNOs, right? MNOs, we talked that they need these macros radios to provide this full coverage. When you look to private networks, there are some use cases, for example, Gogo, that they need macros, but normally they use like a smaller coverage, a very confined coverage. So we have created a new portfolio of products called small cells with lower outdoor power, everything based on Open RAN. And then one of the radios that is more important for the private networks is indoor, right, for all these Industry 4.0. So this is driving our hardware portfolio. And finally, another thing that we have learned from private networks, if we go to the next slide, is the importance of integration, right? Integration and interoperability tests. We learned that in Rakuten, where we were there with a big portfolio of vendors, different RAN vendors, core networks, virtual platforms, but this is even more important on the private networks field because there are many players. So we saw the value of being proactive at S-Band and making our software validated with all these partners, right? For example, here we have an example of on the 5G cores, and we have Cisco, Hewlett Packard, Druid, Metaswitch, AutoCore, Cocus, where we have done integration. And that means that our intention is that not just with 5G cores, with RAN vendors, with virtual platforms, with all these ecosystem devices. And the idea here is like we want our software to be totally compatible with any of the partners. So the idea is like our S-Band software will become like a USB that you can connect to any PC and it will work. So these are the three learnings from private networks that is driving the portfolio on the private network side. If we go to the next slide, please. CBRS. CBRS, it's a great market. I mean, there is a big variety of use cases, but there is one that has created new players, right? And these new players are the cable operators, the MSOs. They have been very active during the CBRS auction, and they have purchased, I think that it was that they spent around $1 billion in PAL licenses. So the intention is to really deploy 5G infrastructure to become operators of virtual operators, right? So this is an enormous opportunity, but of course, these are the different use case as a as a major carrier. So what we are working with cable operators is to, to make faster deployment and more efficient related to the assets they have, and the assets they have are basically strands. So if you see in this slide, sorry, one a major carrier will take, their strategies to put a tower with different macro radios, and this can take months, and also the cost is quite high, maybe $100,000. If we move to our way of deploying networks with our software and new radio products for cable operators, you can deploy these radios in days, right? So if we go to the next slide, with this new disruptive wave of deploying networks, first of all, you're saving money because it's just days of deployment, but also the full solution, the full Open RAN solution is much cheaper. I mean, we're talking about less than a tenth of a cost that will be one of these macro towers. And if you can see here on the photo of the right side, the one technician can go with this Open RAN radio, hang it on the strands, and actually the strands itself, they have already the connectors, right? The DOCSIS technology together with the energy. So you just need one cable, and you have a small cell that really defines a nice coverage on that area that they want to cover, right? Because they don't want to blast a whole area. They just want to go precisely to two areas that they want to cover. And we did already a real exercise, a real deployment 2 years ago with a cable operator.
5-minute warning.
Thank you. In New York area. And you can see on the left side was the macro deployments. And of course, this area had a lot of coverage gaps. So what we did with this cable operator was to deploy 20,000 of these radios in less than 9 months, right? And this is a great achievement, right? When you see how many radios can you deploy on a daily basis. So this is the way that we disrupt the market. And also, Open RAN, what it does is that it simplifies the radio itself. It's because we're moving the software that previously was on the radio, we're moving it away. So that the software is lighter, it's easy to deploy, right? And easy to manage. So this is the benefits that we see on the Open RAN. Also, we have seen in the US that cable operators have been very vocal on the support of Open RAN and going to the cloud. So if you go to the next slide, let's talk about the products. So these are the three trends that we see, and now I summarize the products that we have related to these trends. So first of all, let me see what we do as a company. So we go to the next slide. This is the diagram from Oran Alliance. If you see, the green square is actually what is called the radio, the G-Node B, right? And there are three major parts. There is the hardware, that is the radio. There is the DU and the CU, that is the software. So I think it's very important to really differentiate about end-to-end Open RAN vendors, right? I think we are, in one of our differentiators is that we do both. I mean, we are very experienced doing software with our plug-and-play technology and simplicity of deployment, right, that we are bringing to 5G, but also we are very good creating hardware, right? And this experience gives us like these system skills level of integration and vision for Open RAN. So we are capable to do software and also to design and deploy our own radios. On the second part, these red squares on the top, this is the RAN Intelligent Controller. This is this new entity from Oran Alliance that gives this extra intelligence. It opens the radio to third-party software companies to put extra intelligence to improve the performance of your radio. That this is one of these major needs for private networks. So if we go to the next slide, if we look at our software portfolio, next slide, please. Thank you. So we do the software, the VCU, the VDU, right? Everything containers, cloud native software, following all the features from 3GPP and Oran Alliance. Then we bring on the software side what is called the Airspan Control Platform. Is an EMS that controls and manages our radios. Of course, you can take a third-party EMS and control our radios. That's totally fine. We also created a CBRS proxies to do the agreements with the SAS and PAL licenses. And also, if you see, we created these RAN intelligent controllers that we are developing, and this is this extra intelligence that Open RAN provides for the radio. If we move to the products, next slide, please, and the following one. This is the summary of what I have explained. First line of products that are available now is the macros, right? You can see here the sub-6 macros with high number of radio antennas. Then we have the millimeter wave, also with 128 antennas. This is the one that is used in Rakuten. Then we go to the right, we see the strand, that is an ideal radio for strands to be used for cable operators, but also in other countries like India or Japan. There is a lot of strands there as well. We have the small cell outdoor that in the future will be used by MNOs, but currently the main market is private networks. And then if we go to indoor, we have Extend's indoor portfolio. We have the millimeter wave that's being deployed now on Rakuten. And then the second one that you see there is the sub-6 radio that, again, will be like a third priority for MNOs, but currently is one of the main products for private networks. And the last one, the AirStar, is a new concept of indoor radio that is capable to give coverage outdoors as well. It's got 2 antennas, right? And this is for simplicity of deployment. So this is our full portfolio. You can see here with the gray circle, the ones that are supporting CBRS. So it's ready for CBRS market. And this is S-band. So we are very proud with our 5G portfolio, Open RAN, and happy to serve you. Thank you very much.
Thanks, Abel. And next, we're going to hear from Anil Bhandari, the Vice President of Product Management at Altiostar. Anil, the floor is yours. Anil, can you hear me? You might be on mute.
Oh, my apologies. I was talking on mute. So good morning, and thank you to the Commission, Brian. So in today's presentation, I'm going to focus on Open RAN architecture and its benefits. And then I'll focus on Altiostar solution maturity. And finally, I'll wrap up the presentation by briefly summarizing approaches towards Open RAN system integration and deployment. Next slide, please. Can we move to the next slide, please? Okay. So a little bit about us. Altiostar, we are a provider of 4G and 5G open virtualized RAN solutions. And by open virtualized RAN solution, what we mean is that when we started Altiostar, we felt that mobile industry is on cusp of transformation with 5G, which is similar to the one that occurred in 2000s when networks moved from voice architecture to support both voice and data. And we also looked at 2 key drivers, one of which was that with 5G, networks are expected to support variety of use cases, mobile broadband, IoT connectivity, and high number of devices, as well as support for ultra reliable low latency kind of connectivity. We also saw that with 5G there will be a move from human-centric to machine-centric communication, and many of these cases would be consumed by enterprises. So considering these key drivers, we felt that there is going to be not only a technological but also a business transformation to meet these requirements, and we require a network which supports realizing various use cases programmatically from virtual functions. So considering all this, we developed our virtualized and disaggregated RAN solution. Today we have a mature open vRAN solution that is commercially deployed at scale across 4G and 5G. As a company, our headquarters is in Boston, Massachusetts, and we have built a strong strategic partnership with industry leaders such as Intel, Qualcomm, and Cisco. And these partnerships have helped drive innovation in the RAN industry, which was until now dominated by the black box solutions. We have received investment from companies such as Rakuten, Telefonica, Qualcomm, who believe in our vision. And our effort and innovation has been recognized by industry, and we have received several awards. We have been working closely with organizations such as 3GPP and ORAN Alliance to make sure that the solutions are based on standards. These solutions are based on standards and supporting open interfaces. Next slide, please. So there is significant movement for adoption of Open RAN networks due to the transformative nature of the technology, as can be seen from this slide. And as a company, we are engaged with several operators worldwide, including both brownfield and greenfield. We have implemented several advanced features, and we have demonstrated highest level of performance with these different operators. Next slide. So this slide shows the Open vRAN architecture with Altiostar solution. And here, as you can see, we are supporting open interfaces. These interfaces are based on 3GPP and ORAN. And basically, it is the architecture is based on the principle of separation of concerns. So the signal processing functions have been now virtualized, and they run on COTS hardware and can be deployed in the cloud, whereas radios are interconnected with these signal processing functions over standards defined ORAN option 7-2X interface. The architecture provides tremendous flexibility and helps operators realize different deployment models, whereby the signal processing functions such as DUs could be either located in the edge data centers or can be deployed at the tower locations, depending on the quality of the transport that is available in the network. And typically what we have observed is that operators have a mix of transport. In dense urban areas, they have optical transport. So in such cases, the DU functions can be deployed along with CU in the cloud, in the data centers. Whereas for the rural locations or far-flung locations, the DUs can be deployed right next to the radio at the tower base and connected to the CU over microwave. Another point to be noted here is, as I have shown at the bottom of this slide, the small cells are also connected to the same CUs. So basically, it provides for a converged architecture whereby small cells are also being managed from the same CU. And this has tremendous benefits in terms of reducing the operational complexity, and also it provides the ability to carry out troubleshooting if any subscriber is facing any problem in a comprehensive manner and quickly. So that improves the subscriber satisfaction. Apart from this, I would also like to highlight that with this architecture, it is now possible to realize different use cases depending on the specific requirements for that particular use case. And we will see that in the next slide. So can we move on to the next slide? So as shown in this slide, in 5G, there is requirement to support slicing, and with slicing, there would be use cases where there may be a requirement to support, for example, low latency. And for such low latency, the user plane functions have to be hosted near to the cell site. And in that case, the virtualized CU-UP can be instantiated programmatically near to the tower, as shown here in this chart as VCU-UP2. And then, of course, there would be use cases which are typical mobile broadband use cases, in which case, the resource benefits of statistical multiplexing can be realized by having UP hosted more centrally, as shown through VCU-UP1. So to summarize, with Open Virtualized RAN, it is possible to achieve different deployment models flexibly and programmatically. Can we move to the next slide, please? So with the availability of the shared spectrum, now there is interest from the several private companies to deploy their own enterprise private 5G networks. And again, the open virtualized RAN architecture provides a very simplified deployment model whereby operators can or the enterprises can deploy now RAN in their data centers because the signal processing functions have been virtualized. Also, with all the automation that we have implemented, the Open vRAN provides same level of simplicity which is available to the enterprises through the managed Wi-Fi. So this is again another key benefit of Open Virtual RAN. Next slide, please. So this slide shows the disruptive new model that is brought by the Open Virtualized RAN solution from Altiostar. So on the left side, we are showing various architectural benefits. With our architecture, we have disaggregated hardware from the software. And as a result, now the benefit is that this lowers the barriers of entry and allows participation from innovative niche players. We are already seeing that in a very short span of time. There are now several new radio vendors who are already who have brought their products, mature products. We have integrated with these products, and these products range from small cells to complex hardware such as radios. Also, now that the software is running, the signal processing functions are running as virtual software on top of COTS hardware. That provides for higher velocity of innovation. The features can be now implemented in software and brought very quickly. And then obviously, the virtualization is providing benefits of data center economics. Also, one of the things that I would like to highlight here is that Altiostar plays the role of certifying the end-to-end solution in this model. And we also play a key role in making sure that we integrate with all the solutions components such as radios, OSS platforms, as well as the orchestration platforms. So that way we provide operator peace of mind that they get an end-to-end solution. In addition to this, I want to highlight here that Altiostar also has a hardware reference design team, and we provide our reference designs in case operators find that they don't have a solution available from the from the market. Next slide, please. This slide shows that with the open RAN, with the open architecture, there is participation from US companies in the entire ecosystem, whether it is the cloud software, radio, transport, security. So there is this whole paradigm has enabled participation from the US companies in RAN market. Next slide, please. This slide is showing the benefits from using an open virtualized RAN approach and the automation that it brings. So today in Rakuten, as an example, cell site commissioning takes 8.5 minutes for 4G and 4 minutes for 5G. And this is, it has to be seen in the context of the time that is taken with the traditional approaches where the commissioning would take days and months. So with all the automation now, it is possible to commission a site without any human intervention. And that basically improves, again, time to market, and it reduces the involvement of operator personnel, which again further reduces the TCO. Also, new feature deployment, again, the feature deployment velocity has improved tremendously with this approach because of the now ability to use techniques such as secure CI/CD and so on. And also the fact that the features are now being developed in software without any dependency on the hardware. Next slide, please. This slide shows the maturity of the Open RAN solution from Altiostar. As you can see here, our software availability is better than 5 nines. And today, Rakuten has deployed our software across thousands of macro as well as small cells and cutting across 4G, 5G, millimeter wave, and massive MIMO technology. Our software is at the heart of the network. Basically, our software, Open vRAN software, is driving the hardware that has been supplied in Rakuten network by companies like NEC for massive MIMO, Airspan for millimeter wave, and so on. Next slide, please. So this slide just provides few additional details. As I mentioned earlier, our software is supporting both 4G, 5G across FR1, FR2. We support both 5G NSA as well as SA-based architecture, and we are supporting ORAN front haul 7-2X interface. Next slide, please. We are so for the deployment of Open RAN, there can be different models. That's what I'm capturing here. There could be operator-led model, and this is what is being done by Rakuten and Dish. However, we are also offering solution provider-led model with companies such as IBM, NEC, Fujitsu, Tech Mahindra, WWT, providing their services to the operators. So they are the ones who aggregate various components. We work closely with them to develop solution blueprints, and they provide operators same single throat to choke kind of approach, which is being provided by the traditional vendors. And finally, with the virtualization, it is possible to offer RAN as a service. And in this model, there is no effort involved from the operator side or from the enterprise. They get package service, and they just deploy the radios, which is PNF, in their network. In all these models, Altiostar acts as trusted advisor to design, certify, integrate, and support end-to-end solution. So we develop the blueprints. We work with various vendors that have been selected by the operator. We also help operators in writing down the requirements and vendor selection process. Finally, of course, we also run the IoTs, and we take the responsibility for providing KPI assurance. So this is my last slide, and I would like to stop here. In closing, I just want to say that we talked about benefits of Open RAN and how it will help drive innovation. We talked about maturity of Altiostar's Open RAN to support 4G and 5G in greenfield as well as brownfield deployments. So with that, I appreciate the opportunity for presenting on behalf of Altiostar. Thanks once again to the Commission. Back to you.
Thanks so much, Anil. And next, we're going to hear from Matt Mellister, the Senior Vice President in the Office of the CTO at CommScope. Matt, the floor is yours.
Okay, thank you. Can you hear me okay?
Yes, we can.
Okay, good morning. As introduced, my name is Matt Molester. I'm the CTO for CommScope's indoor and outdoor business segments. Today, I'll provide an overview of CommScope's Open RAN strategy. Could you go to the next slide, please? For those in the audience that may not be familiar with CommScope, I'll provide really a very quick overview. We are a public traded Fortune 500 company headquartered in North Carolina with revenues in excess of $8 billion. CommScope is exclusively devoted to the telecommunication industry, amongst the largest US-based suppliers for telecommunication infrastructure equipment. If you access the internet at home, at work, or on the go, whether it's through wires or wirelessly using licensed or unlicensed spectrum, CommScope likely helped enable it. If you go to the next slide, please. Thank you. Through the various companies that we've acquired, CommScope was there at the beginning of cable television, both private and public radio, networking, and Wi-Fi, playing a key role in shaping the technologies and the standards behind it. ARRIS, who CommScope acquired in 2019, has been the leader in DOCSIS technology for the last 20 years, as broadband connectivity migrated from video to broadband internet access. Last year, CommScope delivered just short of $3 billion in broadband access equipment. When the data centers moved from on-prem to hyperscale data centers, CommScope was there with solutions to support higher speeds and massively parallel architectures. Ruckus, which CommScope acquired in 2019, embedded many solutions to improve voice, video, and data over Wi-Fi, including the use of adaptive antenna arrays, dating all the way back to the early days of Wi-Fi. CommScope is also a leader in providing in-building coverage solutions with a track record spanning 30 years. Our solutions can be found in some of the most iconic venues, such as the Burj Khalifa, the tallest building in the world, the longest tunnel in the world, the holy city of Mecca, the Hong Kong Metro, where we supplied the first multi-operator infrastructure in a metro some 25 years ago. And closer to home, our solution can be found in 7 of the last 10 Super Bowls. Not including Huawei, CommScope is the largest supplier of base station antennas with sales of $1.2 billion for key 4G and 5G equipment. Many of the same principles and objectives of O-RAN have been played out or are being played out in these parallel industries. CommScope is fortunate to see across the complete telecommunication landscape. Could you go to the next slide, please? The motivations behind Open RAN are clear and also well publicized: protecting national security, driving supply chain diversity, reducing deployment and operational costs, and to spur innovation through competition. While the governments are interested in protecting network security and ensuring 5G leadership, most operators we talk to are looking for Open RAN to drive down costs and the ability to introduce new features to the market that will help them monetize 5G faster. Mass adoption of Open RAN is contingent on delivering all these objectives. This is going to take some time, and it's going to require a sustained commitment, and not just from a lot of us vendors speaking today, but more importantly, from the leading operators. We could go to the next slide. O-RAN Alliance plays a vital role in driving a virtual disaggregated RAN architecture, and does this based on comprehensive open interfaces and test protocols to ensure component compatibility between these components. Great efforts are being made not to repeat past failed attempts. For example, CIPRI, which had the intention of being an open interface, but ultimately became effectively proprietary, comes to mind. O-RAN in its complete implementation spans 6 major entities and 11 different interfaces. CommScope, like most of the companies on this call, actively participate and contribute to the various O-RAN Alliance working groups. For the remainder of my presentation, I'm going to highlight CommScope's 5G strategy and our adoption of the various O-RAN standards. Next slide, please. Our 5G and Open RAN strategy leverages 2 fundamental core competencies: CommScope understanding and experience in in-building coverage solutions, and our base station antenna technology combined with our engineering and manufacturing skill to be able to deliver these solutions to the market. With this in mind, our strategy is to provide an end-to-end 4 and 5G platform for the indoor and large public access venues. While we will support compatibility with other vendors' subsystem, our goal really is to provide a differentiated end-to-end RAN solution. In the outdoor space, we have a different strategy, which involves partnering with existing and new RAN and radio providers to integrate our antenna and filter technology into their solution. I'll add some more color on that later. We could go to the next slide. Thank you. Good. For indoor and public access venues such as airports, metros, stadiums, arenas, and the like, excuse me, CommScope provides a comprehensive end-to-end 5G and 4G solution. We also include design and turnkey services as well. Our small cell platform, which we call OneCell, as its name implies, shares a single cell across many radio units. This is in contrast to a dedicated cell for each radio. Because OneCell uses spectrum more efficiently, it's particularly well suited for public and private 5G networks where bandwidth is limited. By creating a single supercell, there are no handovers and there's no interference between the radios. The OneCell radios actually work together to jointly transmit and receive from multiple radios where there's overlapping coverage. This is the same coverage area where a standalone small cell performs at its worst. And then, in turn, this provides a more uniform throughput experience throughout the entire coverage area. Despite 80% of the traffic originating indoor, the adoption of indoor small cells has been relatively slow up to this point. We believe OneCell helps solve the issues that have held small cells back. Our 5G small cell platform builds on our 4G architecture, which includes many aspects that later became foundational in 5G and O-RAN. For example, our 4G radio, which we first demonstrated in a live network all the way back in 2014, used an intra-PHY split with front haul over standard Ethernet LAN. O-RAN recently has introduced specifications for sharing a single small cell, much similar to what we do in OneCell across multiple radios. They call this shared cell. CommScope was a contributor to this work and has also agreed to license our related IP to all O-RAN members. Our OneCell platform embodies the principles of Open RAN and is compliant to most Open RAN specifications, which I'll go into detail next. Next slide, please. Thank you. First, our OneCell radio is compatible with the Open RAN front haul specification. When deployed with our CommScope DU, we use a modified O-RAN interface to implement distributed MIMO that enables OneCell to create up to 8 virtual cells while still appearing as that single cell. This provides a potential to increase capacity 8 times of that of a single cell. Distributed MIMO, initially implemented in our 4G platform, is also being addressed in O-RAN. By supporting both interfaces, both the standard Open RAN 7.2 interface, our hybrid interface, CommScope is able to offer a differentiated solution while still providing compatibility with any Open RAN compliant DU, regardless of the manufacturer. Another unique feature of our OneCell radio is that it houses up to 4 different radio modules in a single radio. These radio modules can be used to provide multiple bands for a single operator, or can be used to operate used to support different operators in a multi-operator deployment. The different radio modules can also be a mix of 4 and 5G, or be used to create both a public and private network using the same radio. Along these same lines, O-RAN is working to define interface and messaging protocols for what they call shared RU. Could you go to the next slide, please? Our OneCell DU and CU are fully virtualized, and they run on standard Intel 86 processors, and they're compliant with 3GPP and the northbound O-RAN interface specifications. A single DU supports up to roughly up to 500,000 square feet for a 100 megahertz C-band carrier, or double that area for a legacy 20 megahertz FDD channel. CommScope's SMO, or Service Management and Orchestration Entity, is built on ONAP framework and is compliant with the related O-RAN specifications. This allows integration with a third-party SMO if desired. Today, our near real-time RIC currently resides within our CU, but we plan to move this out of the CU into a standalone entity, again to allow for a third-party standalone application to be substituted. We go to the next slide. As mentioned, our outdoor brand strategy is different. Here we have longstanding relationships with this existing OEMs. We also believe there's still high entry barriers in the macro space for a new RAN supplier, at least at significant scale. Rather than competing with the legacy OEMs in the space, CommScope has chosen to focus our end-to-end RAN strategy developments exclusively for the in-building applications, as I've already said, because we'll be coming from a position of leadership in that area. We also do not intend to provide radio units. Qualcomm, Analog Devices, Marvell, Xilinx, just to name a few, are offering O-RAN compliant silicon that implements a significant portion of the radio unit. As a result, we believe non-massive MIMO radios will quickly become commoditized. This is low-hanging fruit for Open RAN to demonstrate how it's driving down cost. And we believe this heavily favors existing ODMs, overseas ODMs. However, where we see the bigger challenges is in massive MIMO radios, where the antenna is more complex and the number of required antenna variations are high. This is where we believe CommScope can add the most value. With advancements in integrated circuits, as I previously mentioned, there's many companies that are capable of building the active portion of the radio. However, most of these companies have modest, if any, antenna expertise, certainly not decades worth. Today, CommScope ships hundreds of unique models every year, and each year we launch in excess of 100 new designs to address new emerging operator requirements. We believe CommScope can help enable more companies to offer competitive massive MIMO radios. Again, our outdoor strategy is to partner with new and existing OEMs to supply the antenna subsystems for massive MIMO radio units. Of course, we'll continue to supply standalone antennas for the non-massive MIMO deployments as we have for the previous 4 generations. This gives the operator the freedom to independently choose the best antenna and the best radio for the networks. And the antenna systems can be updated as needed without a wholesale rip and replace the radio unit. Based on our experience in the past generations, the antennas are replaced about 3 times as often as a radio unit. An open interface between the radio and the antenna subsystem helps avoid vendor lock-in and costly upgrades. Now, this is a new concept, and in order to promote this modular CommScope is developing a complete 32T, 32R O-RAN compliant radio subsystem. Again, this is not to intend to be a commercial supplier. This design is being offered as a reference design as part of Facebook's Evenstar project. We will also use our internally developed radio for validating and demonstrating our antenna calibration algorithms. Another key area we think for massive MIMO, and another area where we think CommScope can differentiate itself. You can go to the next slide. CommScope is also helping operators solve problems with limited tower space. This is an issue for many sites, and it slows down 5G deployments. Here, the concept of the antenna filter unit that I showed in the previous slide is being extended to to integrate a massive MIMO radio with a legacy antenna that's servicing the legacy bands. This is being done to reduce space and wind loading. This concept is known in the industry in general as an integrated passive active antenna, or often called IPAA. Here the concept here in this slide, the concept is where the massive MIMO radio unit mates up to an antenna assembly that houses the legacy bands. At CommScope, we refer to that mating assembly as the Universal Pass Module, or UPM. What makes this solution more than just a cutout in the back of the UPM is the use of our patented technology, which enables us to interleave the massive MIMO antenna elements with the legacy antenna elements housed in the UPM. In essence, the antenna system of the new Rate 5 massive MIMO radio is able to see through the legacy antenna elements without distorting the pattern of either antenna. This technology sometimes is referred to as antenna cloaking. CommScope and Huawei were the first to introduce this technology to the market. And what this does is it allows us to put these two systems together in a single package without appreciable increase in tower space or wind loading. Can we go to the next slide? Sorry. So in closing, O-RAN is an important step in the RAN evolution. Driving virtualization and standard interface will drive innovation, it will lower costs, and it will enable new domestic suppliers to enter into the space. While necessity is the mother of invention, competition is the mother of innovation. CommScope recognizes that for an ecosystem to dramatically change, there must be great effort, a long-term vision, and significant collaboration. CommScope is committed to a more open ecosystem which is governed by innovation and cost efficiency. I appreciate your attention today, and thank you. That concludes my talk.
Thanks so much, Matt. Next, we're going to have a joint presentation from Stephen Bai, Executive Vice President and CCO of DISH, and Ishwar Parukar, the Chief Technology Officer at Amazon Web Services. Stephen and Ishwar, the floor is yours.
Oh, very good. Well, thank you for the introduction. I'm again very honored to be presenting on behalf of DISH and doing a joint presentation with AWS, who is a very important partner for us as we're on this journey building a cloud-native 5G network here in the United States. As many of you have followed, it's an exciting venture that we're on, building a greenfield network, taking advantage of O-RAN and the environment that we have today. So it's a very exciting time for the company, and we're very pleased to be working closely with AWS to be able to launch this. So if you could, I'd like to move to the next chart. So, our vision, and we've talked a lot about this in the press and on our earnings call, is really to build the next generation of network. And we've deliberately focused on sort of O-RAN in terms of the base station infrastructure. But perhaps one of the most important things about what we're doing is it is cloud native. And the architecture throughout the network, from the base station all the way through to the core and even all the way up through our OSS BSS environment, is really with a cloud native construct. And, when we looked at this and we embarked on this journey, we really started a couple of years ago. We had options about what do we deploy in terms of the radio technology, and we decided very deliberately that we'd start with 5G and really move forward and not bring the legacy of 4G and even prior technologies with us as we did this. And coming into the market at this point in time, really was an important decision for us, and we think a confluence of factors allowed us to do this, which makes it very exciting. The other thing is, and again, just to emphasize, it's really all the way from the core, the entire stack that we're putting in place in terms of the support systems, all the way down to the base station and the radio. And that's what's exciting about the architecture that we're deploying, but also unlocks a lot of really interesting opportunities. And, I reflect back on my career and looking at how hard it was to scale platforms and, put more compute and more processors in to handle busy hour call attempts, on switches and the like in the past. If you go back 10, 20 years, things took a lot longer to, build a scalable platform. And today what we can do is really remarkable and amazing within the cloud. And so the scalability is really important. With the architecture, we also have the versatility as we introduce new spectrum bands and how we deploy those and integrate those from the DU all the way back up through into the core. This platform really changes the game there. And we have other capability with slicing, and then really, and I'll go all the way to the end here, it's really about a software-based platform. And, the way to think about this, and, while we talk about it as a sort of a telco cloud, it really is more of an IT software-driven platform that we're deploying. as opposed to a traditional vertically integrated hardware, software integrated solution throughout the entire network. And so it's really turning the network sort of horizontal and allowing us to decouple, the development in terms of the hardware and the capabilities that we can embrace as, as that continues to evolve, and then layering the software on top of that and having that development cycle move at two different paces and being able to integrate that. So we're very excited about what that does. And then the other thing which we touch on as we look at our vision and how we're operationalizing this vision is the amount of data and visibility we have at every layer within the network and what we can do with that data in terms of the analytics and how we can apply different machine learning and AI to that data that we have, all the way down to the radio interface. It's just tremendous the amount of data that we have visibility into with this open architecture. And that translates into how do we deliver a disruptive customer experience, and then how do we deliver a different level of experience taking advantage of all this information that we have access to within the architecture. So if you'd like to move to the next chart. So, we often get asked about where we are in our deployment, and we've not announced markets, but I can assure everyone that, work is well underway. We have some very important milestones that we need to hit, and we're making very good progress against that, or those milestones. And so, first most important one that's coming up is really to hit, 20% of the population by mid next year. We're well on track with that. The deployment teams are working very hard across the country, in many, many different markets. And, every now and then, people will see that, we're putting cell sites on air, but there's an enormous amount of activity, and we have teams in place in markets throughout the country working on that right now. What was very important to us, and we talked about this at the end of last year, was sort of the technical validation of O-RAN. There's a lot of questions in the industry around, is O-RAN ready? Can you really do this? And, we spent a lot of time last year getting underneath that, working with our key partners to validate the technology. And we did that at the end of last year, and very, very pleased with what we saw and the success of the technology, working with different vendors and different partners that we have in our ecosystem. And so we're really in that execution phase now. We're comfortable with where the technology is, and now it's about, getting the network deployed and scaled up. The next milestone that we have is really important again, which is, hit 70% of the population by mid-23. Our commitment is to have a minimum of 15,000 cell sites, and we're well on track to achieve that objective as well as we scale our deployment and the construction activities that we have underway, working with our key partners on that one. And then we have another milestone in 2025. Again, the first couple are probably the most challenging in terms of getting the momentum moving in terms of the build, but that's well within our reach in terms of the 2025 objective. And then the other interesting thing is we are working in the enterprise space even today, and talking to a lot of different companies and working with customers on private 5G networks. And so we have activities underway this year even on that, because we can go down a path of deploying those in parallel with as we build out our macro coverage. So it's very exciting to see the amount of traction and interest within the enterprise market space as it relates to private networking. And again, we're bringing sort of this open architecture into the private 5G space, and allowing that scalability as well as a path towards 5G as we look at how do we operationalize their businesses and make their businesses more efficient. So that's really exciting for us as we move forward as well. If we can move to the next chart. So, we look at our network architecture, and Ishwar is going to talk a little bit about where does AWS fit within this architecture. And one of the things that I thought was helpful would be to lay out how we look at the network. And then Ishwar will talk about, where does Amazon and AWS fit to be able to support us. But what's really interesting to us is, when we look at how we're deploying it, from the base station, we're down the path of, deploying RUs and DUs. It's a 5G native RAN. We're putting a 5G SA core in place. We're serving enterprise customers from a radio access perspective in the private networking space. But then we've really got sort of local data centers and national and regional data centers. And really everything we're doing is sort of from a software perspective. So, we're putting the core functionality in each of these different data centers. And when we looked at this architecture, as we were deploying it, we're like, well, why would we, deploy a vertically integrated solution that coupled us to the hardware why not take advantage of the cloud and the data center development, as well as sort of where processors and computers going in the future, as well as storage. So, it's interesting. A lot of people talk about, what's the use case for MEC and the edge. Our network is the use case for that. And so, we're really putting our network software and our network functionality all the way down to the edge. And the wireless network itself is the customer of that MEC and taking that platform all the way down to the edge. So, that's what's exciting about what we're doing. I think it's also important to point out that, it's not a lift and shift. We're not just simply taking software and dropping it onto, the AWS data centers. This is an important point. What we're deploying is really a cloud native architecture. So at every component within the network, as we look at the software and how it's developed and how it's put together as a solution, it is a cloud native, cloud based solution all the way up. And that's what's exciting about what we're building and what we're deploying. And that's why we say it's, really the America's first cloud native 5G network, because, no one else is doing this, and certainly not at the scale that we're doing it across the country. So if you'd like to move to the next chart. And I touched on this a little bit, it really is kind of an industry first. And, many of our competitors actually didn't deploy nationwide networks. They were really a combination of different regional networks that got consolidated and brought together over time to create national footprints. So, what we're really building is a nationwide network, coast to coast, border to border, and we're building it as a cloud native network. And so, that allows us, even though it's a sort of a telco wireless network, we're really embracing what we can get in terms of the software ecosystem and working with a lot of partners here in the US and smaller vendors, as well as bigger vendors and partners that can bring US technology into our network. And that's what's really exciting about what we're building as a platform, because, it really helps bring that ecosystem together here in North America. But it also allows us to take advantage of the innovation and the pace of innovation that we have here with small companies and big companies is just phenomenal. And so when we look at how we onboard those partners, through CI/CD, as well as sort of the automation and the model that we have with AWS, that really helps us move that along. I think it's also important to point out that, AWS is developing their platform, and Ishwar will talk more about this, but, they're building a really solid architecture underneath us to allow us to be able to take advantage of technology like Graviton2 and Nitro, and as they evolve Outpost and where they take that platform as well. And then in terms of the ecosystem development, the APIs and the exposure that we can enable, and it isn't simply just, here's an API from Dish and here's an API from AWS. It's how do we integrate those to support Industry 4.0, and how do we deploy a capability that not only allows us to deliver a better product and capability for our consumers, but it allows our platform to be exposed to enterprise customers to allow them to take advantage of this environment to support their business model and support the operational efficiency they're trying to get out of being able to take advantage of the cloud as well as wireless access. And then the other important point, and this is something that I've talked a lot about in different forums, is the security model. It's really important in terms of the security architecture. And we talk about sort of a software supply chain and really having a software supply chain of trust. It's really important as we look at how software is introduced, where it's introduced by our partners. How do we validate that? How do we manage the deployment of that software throughout an environment is really, really critical. And the open architecture and O-RAN really gives us much more transparency and visibility throughout every layer of the stack and throughout every component of our network. And we believe that is really vital as we go forward, not only to protect our network, but to protect our customers that are using this network as well. And so, we lead, the US leads the industry and the world in terms of the security models, and working with Amazon, we can put those into place and reinforce our network as well as supporting our customers. So it's a very exciting partnership we have with AWS. It's a strategic relationship we have, and it has a huge, it is a huge component of what we're doing. It complements what we're doing on the radio in terms of O-RAN and the deployment of that open architecture. But we're also building this cloud native environment that really scales. It helps us on the operating efficiency, and it also unlocks new business models as we go forward. So it's an exciting development for us, and we're very pleased to be partnering with AWS in this approach. So with that, I'll hand it over to Ishwar.
Thanks, Stephen. Next slide, please. Yeah, my name is Ishwar Parulkar, and I'm the Chief Technology Officer at Amazon Web Services for the telecommunications vertical. The cloud has become the de facto way of deploying applications for enterprises over the last several years. And a few years ago, we started looking at how this could be applied to building networks and looking at network workloads. And more than a year ago, we started collaborating with Dish, as Stephen mentioned, to see how we could make a practical implementation of some of the technologies we have and build a commercial network and achieve the vision that Dish had. We started looking deeply at how the benefits of cloud could be brought to the network. And what we are doing in building this network jointly is bringing some of the benefits that you see here. So first is total cost savings in terms of CapEx as well as OpEx. So we're using our existing footprint of data centers, edge data regions, edge data centers, and backbone and other network assets that we already have to build out the infrastructure that's required to host all of the network functions from the core to the RAN. And this is resulting in significant reduction in the total cost of ownership versus traditional way of building. The second one benefit that we're bringing is around improving the productivity of staff. In the cloud, we have focused over the years on making applications self-serviceable as well as totally automated. You don't require any manual intervention to manage those applications, and we're bringing that to networks in this joint effort. The third one is around operational resilience. The cloud has always focused on high availability and security through the stack from silicon right up to the higher layers. We have a construct of availability zones, which are data centers separated by geographically so that you don't have any common faults, and all the applications are built using this high availability architecture. And so we're bringing that to the network, mobile network, by using a cloud native underlay to host the network functions. The last one is around agility, the software development and deployment models that we use in the cloud. Traditionally, mobile networks have taken a lot of time in terms of doing upgrades. Whenever you have to do an upgrade, either there's a scheduled maintenance or it takes time to test, validate the equipment and software, and then put it into production. In the cloud, we continuously upgrade and patch software and release new features without any downtime. And that's the other capability that we are bringing to networks and really transforming the way that you can manage these networks in a very agile manner. Can you move to the next slide, please? So Stephen talked about their network architecture and vision, and this slide here shows how we are mapping our cloud assets to that architecture. So on the left side, we have our regions. So we have 4 regions in the US, 2 on the east side of the country, 2 on the west side of the country. And we are using these regions to host the control plane functions of the 5G core and the OSS BSS systems. So this maps to the national and regional data centers that Dish has. Then we have AWS local zones, which are AWS managed infrastructure close to metropolitan areas and large populations. We are building 15 of these, and these are the edge data centers where we are hosting data plane of the core. We also have Direct Connect, which is a connectivity offering we have, which we offer to our enterprise customers to connect their data centers directly to the cloud with high performance, very low network jitter, and a high quality of service. We are repurposing this and enhancing this to serve as the transport backhaul between the edge data centers and the cloud. And lastly, we have AWS Outposts, which are actually, again, AWS racks, which can be hosted in any site outside of our infrastructure, outside of our data centers and edge data centers. And we are using these to host the ORAN components. So we have AWS Outpost racks, which can be hosted in aggregated traffic aggregation sites. But we're also developing 1U, 2RU, very compact form factor versions of Outposts, which can host DU, the DU components in cell sites and very constrained type of locations. Also, they can be used in the private enterprise, private network scenarios as well. Next slide, please. We can skip this slide. Next one. Yeah, so there are some key underlying technologies we have worked on specifically to address the fact that we want to run mobile networks on public cloud. So the first one is the Nitro stack. This is our virtualization stack. And what we have is a dedicated Nitro card, which we use to offload compute, network, and storage management functions, resulting in a very thin hypervisor layer. With this, what happens is we get all the benefits of virtualizations, but with performance that is very close to bare metal. Secondly, we are using Graviton2 processor, which is an ARM RISC processor, where we are seeing up to 40% price performance improvement over the most demanding performance workloads, as well as up to 20% savings in cost compared to similar instances. We believe this could be a game changer for deploying O-RAN workloads, and our 1U, 2RU, the servers, the small form factor servers we are building are based on the Graviton2 processor. Most of these network functions are now containerized, and we're using Amazon EKS, which is our managed Kubernetes service, to deploy these network functions and orchestrate them. And we've looked at specific features here that make sure that this can be done with high availability and high security. As an example, the control plane of EKS is replicated in the availability zones in the region, which gives a very high availability model for running these network functions. Lastly, as I mentioned, Outpost is a very critical component of the end-to-end network. This is, again, AWS racks, the same ones you use in the region, but they can be deployed anywhere right up to the cell sites. And we've built this with a fundamental design tenet of consistency of operation and consistency of experience across the regions, local zones, and outposts. So what that does is, in building an end-to-end network, you have a single pane of glass for managing your infrastructure. Any update to the virtualization infrastructure or services that we do in the regions gets reflected right up to the edge in the outposts, the 1U, 2RU outposts that are running at the cell sites. It's all one seamless experience, as well as a seamless operational model. Next slide, please. So essentially, the other key benefit of bringing the cloud to mobile networks is operations, simplifying operations. So we are leveraging the continuous integration, continuous deployment model that we use in the cloud to actually deploying the network functions, upgrading them, testing them before putting them into production, as well as doing maintenance on some of the underlying hardware. We have observability mechanisms like CloudWatch, again, which are very trusted and mature in the cloud world, which are being repurposed for monitoring the network. And also using features such as autoscale, which scale capacity on demand by policies enforced by OSS and BSS systems to result in closed loop automation type of systems. The other key thing that comes with using the cloud or extending the cloud to the edge is the other services that we use for analytics, as well as AI ML. And these we are using to perform analytics to optimize the network, optimize the RAN, as well as do predictive maintenance. Predictive maintenance in both dimensions, in terms of understanding hardware failures, predicting hardware failures, as well as recognizing the fact that you have a need to provision more capacity, links becoming oversubscribed, and so forth. So a key tenet we have is this seamless experience from the regions to local zones to outposts, where we have all of the AWS services available to perform these higher level layers of functions that are required to observe the network, to operate the network, and to perform analytics to do predictive maintenance as well as other operational aspects of the network. This has been a journey that we've taken jointly with Dish, and we are very excited to build the first commercial network using the public cloud. O-RAN is a key component of this because of the decomposition of network functions as well as open interfaces that are being defined. We are expecting this journey to continue to develop more interfaces that can bring the higher layers of services in the cloud to building mobile networks and specifically to the RAN components in the mobile network.
Thank you, Ishwar, and thank you, Stephen, as well for that presentation. And now we're going to have to move on to our final presentation for session 5 from Todd Landry, the Vice President of Product and Market Strategy at JMA Wireless. Todd, the floor is yours.
Wonderful. Thank you, everybody. And a special thank you to the FCC for hosting this important showcase of O-RAN technologies and products, and particularly readiness for implementers of networks out there. Let me start by talking a little bit about JMA's framework and how it really addresses the emerging market for supporting O-RAN and supporting, more importantly, end-to-end solutions in the marketplace. One of the things that's important here, and you heard a lot about this from Stephen and Ishwar on the previous presentation, there's a huge move towards leveraging software platforms that are capable of being virtualized in different levels of the cloud. Important in 5G is the disaggregation of some of this RAN capability so that it can operate in areas of the network and cloud and standard compute areas that make it easy to deploy next generation networks with significant performance, significantly lower latency, and things like that. The other piece of this is we are seeing a massive expansion of spectrum, and we are seeing a significant use of wireless technology, and particularly latest 4G technology for private networks, moving towards 5G technology for both private networks and public networks. One of the things you see here is our overall framework, which on the left, you see we support the full range of spectrum in FR1 and FR2 areas of technology, but then architected in a manner in which it can be applied to different private networks as well as into the macro network. I'll talk a little bit more about what we've been doing here in a bit. Now, at the core of this, one of the things you see is our Open RAN-based 4G and 5G virtualized RAN platform. Now, you're going to hear a lot of people talking about implementation and software out there. We're certainly happy to see that because we started this effort almost 6 years ago, announced live networks with a true virtualized RAN platform nearly 5 years ago. So the maturity and the experience in building full stack RAN technology in software has been something that JMA has been an early innovator in this space. And again, what we're seeing is just validation that we were spot on in what we were innovating in and where we were pushing in terms of delivering virtualized RAN technology. Now, naturally, with O-RAN, there's a set of interfaces. Open RAN split interfaces in this diagram allow us to interwork with different technologies that we build from a radio unit perspective. So at the core of this is our XRAN technology, full stack 4G with CU-DU technology, which I'll show you a little bit more detail on in a moment. But in addition to that, JMA delivers radio technology to fulfill different use cases. So if I look at enterprise environments that you hear a lot about here today with private wireless, in the US market in particular, where it was really the front end of the first delivery of cellular-based private wireless networks using CBRS radio spectrum, we were really one of the first ones to introduce real live networks as the CBRS technology and spectrum opened up several years ago. Since then, we've been deploying massive networks with this technology and enabling private wireless capabilities with this same core engine. The other piece of this is JMA has a long history of deploying radio equipment in some of the largest, most impressive facilities around the world. And what we've been able to do is take those environments and enable the pre-existing RF infrastructure to interwork with O-RAN technology and with our X-RAN technology. What this is doing is it's enabling 5G capability into these environments with little to no changes in the current RF infrastructure that's already there. So a real fast way to enable 5G capabilities in some of the largest venues in the world. In addition, we've introduced our millimeter wave technology, and we approached it not as applying a outdoor technology to an indoor environment. We approached it in building the first fully integrated digital beamforming millimeter wave technology that was really optimized to provide millimeter wave connectivity in in-building environments. Again, all of these in which operate within O-RAN architectures so that you've got a single architecture leveraging virtualized RAN technology to enable that. Now, the other thing you see in here is interworking with Open RAN radio units on the right. So I'll show you some of the PlugFest stuff we've been working on. We've been enabling end-to-end capabilities with third-party radios to enable the marketplace for more of an open system approach to enable people who are operating networks to make selections of best-in-breed components to build for the use cases they need. Now, the other piece that's not shown on this slide is to deliver end-to-end solutions, you have to reach out to the very endpoint, meaning that we have to deliver antenna capabilities all the way out to the edge of the network. We have to interconnect those antennas with different connectivity technology into the RUs. JMA has a long history of building that antenna technology for the largest networks in the world. Today, we're a predominant supplier for some of the largest US build-out of true 5G networks going on right now. So this gives you an overall framework for what we've been building. And again, what it does is it extends all the way across enterprise and into macro networks, as well as spanning it from millimeter wave down into all the FR1 frequency bands. Next slide, please. This is a snapshot from one of the many PlugFests going on. And what's important with O-RAN is this concept of openness. Now, with openness, it means working on interoperability. One of the things you'll notice here is there's JMA RUs in this topology as well as third-party RUs in this topology. The other piece that's important here is we're going through a transformation in many networks where there are 4G network capabilities out there or 4G devices, and they want a clear transition into 5G. This topology allows us to showcase the cloud-based DU, CU topology in a disaggregated fashion. So you can see the 4 key JMA components there, inclusive of all the Open RAN interfaces to get from the core networks on the right to the UE devices all the way out to the left. It can be deployed and operated in using O-RAN interfaces in a 4G network, in a NSA or non-standalone type 5G network, as well as a standalone network, using a common architecture and common software topology. So it is not acquired chunklets that you have to figure out how to integrate. We took the approach of ensuring that you have a common architecture, and we can manage that common architecture as you transform networks into the next evolution of 5G. The other piece that shows is the northbound interfaces. Today, we offer all the 3GPP-based northbound interface capabilities so that the operational systems can be integrated. We support standard Yang model and NetConf interfaces into different operational systems. And then we are rolling out those interfaces to support the RAN intelligent controller interfaces into the entire RAN topology. So this gives you a viewpoint of that. Keep in mind that this topology can be applied to either private networks or public networks. And these are important aspects of what we're doing out there to enable what is really becoming a convergence of capabilities, especially in the private network space, because we're looking at scenarios where neutral host capabilities in these networks using these new software RAN technologies are becoming critically important. Next slide, please. So let's talk a little bit about what we're doing, what's going on, and how we're changing things out in the network, why it matters. So first and foremost at the top, we really spent a lot of effort early on in innovating in a 100% software platform. There are many solutions out there declaring software capability. This is a platform that we've, again, had and matured in real live networks for many years now, and fully control all this software so that we can ensure that we are A, innovating the capabilities needed to run true commercial networks, and B, make sure that we can support those networks and respond to those networks when they need new capabilities or resolutions to issues. Very important in the approach to an evolution of the network is the ability to easily change that software to go from 4G to 5G NSA, 5G NSA to 5G standalone, and do that in a manner where it's very low touch, where it's very easy to migrate that platform. We built networks using this software that utilize off-the-shelf compute engines from the major compute suppliers out there in the industry. We've also implemented this software in live networks today using environments such as the AWS compute and cloud environments to enable cloud utilization as well as local compute services in those networks. So again, very critical to everything you will see as we go forward, and everything you see in the evolving networks with O-RAN is having a very strong suite of software core capabilities. Now, where does a lot of that come from for us? And the other thing I want to highlight and why it's important is something that we're all sensitive to as of late, and that is security topologies and control topologies. Steve, I think, mentioned some of that relative to building U.S. technology. One of the things we've done is tried to make significant investments in U.S. innovation and development centers. Our core software platform and our technology is all rooted out of U.S. development centers. And we have a lot of tentativeness to security practices as we work to build these networks. No place has been more important for that than what we're doing in the Department of Defense, where you'll read more and more about our activities in showcasing next generation defense networking technology using this platform to enable that. Now, moving on, it is incredibly important for these solutions to be single architectures that can integrate both public and private network capabilities. We sometimes think about this as licensed bands and unlicensed bands, which are evolving around the world, but especially in the US market today. One of the things we can do with our platform is support what we'll call multi-operator owned networks. So as enterprises more and more start to utilize this kind of technology for their own private networks, it becomes an opportunity for operators to easily bring their public network service onto that software platform through a common architecture owned by an enterprise, but as an interconnect with different operators. And this has been one of the most powerful attributes of what we've built with our platform that people have responded to. One of the key capabilities that is really a history of what JMA has done is focus on a wide range of different bands, and not just individual bands with different radios, but the ability to have wide bandwidth radio systems that can operate as single or multi-tenant solutions for operators. So today, a common infrastructure to achieve these public and private networks efficiently means that your overall solution architecture needs to be able to support multiple operators and private wireless bands without having to introduce multiple passive networks or multiple radio units across that system to make that a reality. So bringing our knowledge of that capability from distributed access systems, antenna systems, is really important to bring it forward into the world of 5G and Open RAN. A couple other things relative to our history in focusing on building our Open RAN 4G, 5G, vRAN system early on is that we experienced the necessary requirements of the system, the scalability system, and the operations of the system. So today you need to take small form factor compute engines and build 10,000 device capability on those small footprint systems. And it's difficult to achieve that, but we've innovated early on and optimized our software platform to have significantly high capacity, an easy way for you to sectorize and add different capacity to it. In the world of CBRS, there are many requirements for uses in the network. And one of the things that we've focused on is the ability to leverage the full capacity of the 150 megahertz of spectrum, but even more importantly, in the new evolution of these private networks is the ability to slice that spectrum and do it in a way that's very easy in the vRAN, so that what we can do is enable different use cases and apply different characteristics to those slices so it meets the needs of those use cases. So with that, the other piece that's been really important in building this kind of software platform when you get to the reality of deployments is how easy is it to deploy? Now, one is we look at it as software running on a platform, whatever that might be. The next piece you run into is how many other networking components do you need to actually integrate it with external networks? Well, being able to offer the ability to have really easy to deploy software combined with the fact that the way we've integrated the backhaul interconnectivity directly into the software, the way we've integrated the mobile operator core network functionality into the software, not requiring additional gateways or additional routing technology behind us to achieve connectivity, significantly streamlines what it takes to go deploy these networks. So with that, one of the things I'd love to welcome you all to is come and visit us at gmawireless.com. Love to talk to you more about the reality of deploying next generation Open RAN 5G networks. Thank you very much.
Thank you, Todd, and thanks to all of the great vendors we just heard from who offer end-to-end Open RAN solutions. That concludes session 5, and we're a little ahead of schedule, so we'll now take a quick break. Please be ready to tune in promptly at 12:15 for another fireside chat, this time with Andy Thyssen, head of 5G and XG engagement at MITRE, and Santiago Tenorio, director of networks at Vodafone Group, to discuss Vodafone's trial Open RAN deployments. Thanks, and we'll see you at 12:15. Welcome back to day 2 of the FCC's Open RAN Showcase. I am thrilled to now turn to a discussion with Andy Thyssen of MITRE and Santiago Tenorio of Vodafone to learn about Vodafone's trial Open RAN deployments and lessons Vodafone learned that may be relevant to other providers as they consider an Open RAN deployment. Andy and Santiago, the floor is yours.
Thank you very much, Brian. And so my job is to basically play host to Santiago, and so it's going to be a good time to do that. Like Brian said, my name is Andrew Thyssen. I work with the MITRE Corporation. As of February, before that, I was at NTIA, where I led for 5G R&D and standards. I have been, playing in and around O-RAN and looking at it for a long time, right? And I think we've heard over the last day and a half so far all kinds of tangible benefits, right, that can come from the use of O-RAN. And with Vodafone here on the phone today, and Santiago in particular, right, we have an operator, right, who can share with us, substantive information about what they're actually doing in the field with this stuff right now. And so before maybe we get into some of the questions that I have to lead us down that path of maybe you articulating that value, if you tell us a little bit about yourself and what your role at Vodafone is.
Absolutely. Thank you, Andy, and thank you, Brian. So my name is Santiago Tenorio. I look after the network architecture for Vodafone. We are an operator based in Europe mainly, but also in Africa and other parts of the world. And so my pleasure being here with you. Looking forward to your questions, Andy.
Awesome. Now, so just to get right to it, right? So Vodafone is leveraging O-RAN for a diverse set of use cases, right? I think in the UK, Europe, and in Africa. Can you give us a high-level understanding of some of the different types of markets that you're going after with O-RAN, right? Just at 100,000 feet.
Yeah, absolutely. So we've had a number of trials going on. We started in Turkey and India, rural sides of those markets. We have some trials going on in parts of Africa as well. And then we brought Open RAN to Europe. I think we were the first operator to trial Open RAN in Europe, and that was in rural parts of the UK and in Ireland as well. But that was before we announced last November that we would start actually rolling out Open RAN in a big chunk of the UK. So that was an announcement that we made back in November, and a few weeks ago we announced the vendors of that rollout. So it's a reality. It's coming. It'll have 2,600 sites, and we will start this year.
That's awesome. And what are some of the different businesses you're going after? Is it kind of in the 5G space? Is it or 4G, is it enhanced mobile broadband, right, that you're using O-RAN for? Are you going after like rural communities? I mean, certainly, one of the things that we're looking at in the United States is that not everywhere, in the US is sitting on top of a dense fiber jungle, right? And so, the different, uses of O-RAN kind of are predicated on what that underlying infrastructure is. So can you tell us a little bit more about, how you're using O-RAN in some of those places that don't have, a tremendous amount of underlying infrastructure?
Yeah, totally understand that and relate to that. At the beginning, we were targeting mainly rural communities. We thought maybe this could be great in parts of Africa and have a better cost of deployment. I think that was probably also, conditioned by the fact that at that time, when we started playing with this a number of years ago, only 4G was possible and 5G was beyond the horizon. But when we look at it right now, apart from 4G being, good enough, we are almost ready to have basic versions of 5G, what you would say like 5G, kind of FTD-based 5G. And we have line of sight with massive MIMO as well. That would be like, in our case, that operates in C-band. So that would be a 3.5 gig massive MIMO type of thing. That should be available second half of next year. So with that in your pocket, you're not necessarily limited to rural areas only. You may also be able to deploy these in suburban or even urban, or even in the future dense urban, when everything is proved that performance is there and it works. So we are more now thinking that this could be used, and we will use this as in the same way as we're using the infrastructure from an incumbent. So our plan in the UK is to simply replace all the stack that we have there, 2G, 3G, 4G, with Open RAN, and then over time, build also a 5G layer using the same solution. That will target everything from mobile broadband to enterprise to everything in between. Now we will start on rural and we'll progress towards more complex areas, in due time.
Now, so we've been hearing right through some of the presentations over the last day and a half, some of the specific benefits around O-RAN, and you mentioned that one that you were looking at, especially in the rural communities, is the cost savings, right? And I imagine does that come primarily from the disaggregation of of the radio units where you can, pull the CU back into the cloud and right? Can you describe that architecture a little bit and where you see kind of those cost savings?
Absolutely. So I think you're right. So ultimately, I think that disaggregation of software and hardware will lead to benefits in the same way, by the way, that it has led to cost benefits everywhere else in many different industries. So I don't think this will be a different case. But you may not want to expect those cost benefits to realize on day one, simply because the volume is not there yet. So if you compare any Open RAN solution with an incumbent solution that has a kind of million units multiplier, it's going to be difficult, or it'll take time until the economies of scale catch up. However, there is one benefit that you may get since day zero, which is competition. And for us, it's probably the single biggest driver behind Open RAN. The supply chain in the radio has kind of, the choices have decreased to a point that is no longer healthy or manageable. And we need more diversity. We need more optionality. And that optionality brings competition, and competition brings, lower cost, both because the commercial terms are, more challenging for everybody, but also, and I think this is important, because innovation will accelerate. And innovation will, at the end, deliver, more advanced technology with lower total cost of ownership. So I think those are different ways.
Right, and riffing off what you said about innovation, right? I mean, I was reading just the other day that you guys have opened an innovation center where you're allowing people to come in and do things like, have access to development of XApps. Right on the rig, right? And can you describe a little bit about? I mean, because I see that as being a significant, proposition for value, right? I mean, because you could do everything from telemedicine to industrial automation, right? Smart agriculture. Where you guys want to take, that innovation center? Because I think that's an outstanding idea.
Yeah, thank you. So yes, you're right. So and the rig. I mean, when people normally ask, okay, but what's new with Open RAN? It's just, it's just another way to just comply to 3GPP. There's no innovation there. Okay, maybe so. However, there is one way to bring innovation through competition, as I explained. And then there are things that are completely new. And RIC is a great example. You will not find anything like that on any of the incumbent, implementations so far. So I think going forward is going to be a great way to deliver applications that work either real time or non-real time embedded into the radio. So we are exploring that indeed. Now, the logical sequence of events is, of course, first we need to have a very good integration in place. Then we need to make sure that the performance is the one we want for our customers, and eventually XApps will come. It'll be phase 3 of kind of this program, and it also be first, necessarily phase 3 of the lab itself. So integration is what's kind of boiling right now, and having all the vendors, working and interoperating with each other. I am sure that we will go through some, not performance issues, but we will have to debug the system on the field, and eventually XApps will come. But it's definitely a front that we want to explore.
Now you said that first step, right, was integration, right? Can you describe? I mean, so Vodafone is not a small operator, right, by any measure, and so right, you have the resources to actually facilitate, right, and manage that integration. What do you see the integration looking like, right, going forward globally, right? Is there going to be a market for integrators to come in and actually do that work and then resell it into the operator market?
I think so, but maybe not the traditional one, maybe not exactly the one that we've been used to. Because if we just apply what we've been doing to this, and then you buy the hardware off the shelf and the software from someone else, the radio from a third party, and you give it all to a system integrator to integrate it for you, and then the next operator do the same, and then the next one is doing the same, then what is the difference? At the end, you're just changing the label from whatever incumbent supplier to a system integrator. I think first of all, it's very important that we operators, we all work towards the same specification, so that even what we do in Europe, well, is the same for all operators in Europe, but is also the same as what operators are requesting from the US. That will make it much easier for the suppliers to manufacture something that's useful, but that will also simplify the system integration, because then if I am, as Vodafone, I'm integrating myself or with the help of a system integrator, it doesn't matter, a third-time set of vendors with the same specification, you don't need to do that, from scratch, because that product has been already integrated. We may use some, I think, some organizations in between to, to act as a central coordination point, and that would be a good idea. If you ask me, in my view, the likes of Telecom Infra Project, for instance, that would be, a very good place to coordinate all this, and even to become a marketplace where to trade, system integration projects between operators. But the key is to avoid duplication, because that's a necessary cost.
Right now, one of the things, right, that strikes me looking at the standards being developed, right, between TIP and the O-RAN Alliance, and some of the things, obviously that we see out of 3GPP is that the expectation of conformity assessment, right, and how you get from buying product off the shelf, right, to the interoperability that you want to see, obviously, between these different products, to then that performance, right, that you're looking to get ultimately out of O-RAN. Do you have any ideas on how you bridge that conformity assessment to interoperability? Do you see there being a regime much like the RAN 5 conformance test development, coming at it in the O-RAN space?
Yeah, so exactly as you described. So first, there needs to be a very good specification of the interfaces. That's what the O-RAN Alliance is doing for the world, and it's a phenomenal, fantastic job. Without it, we wouldn't be here speaking about this. Then there is a system level specification, which is the one that I said before. It needs not to be fragmented, so that we are all working towards the same requirements and specs. Then after that, the equipment, individual pieces of equipment, they need to be validated. And there is like a first, conformance testing, like acceptance validation. This is not the most difficult problem. And again, like TIP can do a lot of that and can provide badges and can provide testing and can coordinate efforts. But the problem of system integration is harder than that, because that is a one-off effort and system integration is a continuous effort. So if you are an operator in the US and you're gonna take for granted that as a third-time kind of setup works, you need support. You need a phone, where to call when things don't work. You need assurance that at every new release of software, things are going to still be working on the same way. And that is a continued effort, it's not a one-off. So conformity testing, yes, I think that's more advanced right now, so to say, and it can be provided through a, say, collection of batches and a marketplace. But we do need a wider system integration in place, is my feeling.
Okay. And now one of the things that strikes me also about, as an operator, right, being arms deep in the integration yourself, right, and what we heard a little bit from Dish earlier this morning is, that perhaps one of the benefits, right, of being engaged at that level is some of the big data analytics that you're going to get out of, disaggregating the hardware from the software and then being able to touch all that software directly yourself. What kind of data are you looking at trying to expose inside of Vodafone that you can use then to manage and operate the network?
So, okay, so I think on the first place, what we need is to make sure that the performance of Open RAN, when you build your entire single RAN stack with it, is equal or better than the incumbent architecture. And that's enough of a job for the next few months, I think. Now, building on what you said anyway, one part of the system that needs to be in place is, of course, the OSS. that is not being talked about very often, but there needs to be an OSS that lets you integrate your processes, operational processes, and run this network with all the alarms and procedures. And that's by no means that is simple. You may choose to start easy and select an OSS that is very close to the software that you're going to deploy, and that will make it easier. But eventually, one day, we may want an open OSS to be one of the parts that you will integrate. Then as you go forward, yes, you may be able to eventually kind of like not only catch up, but move ahead of the curve and start doing things that you couldn't do with a traditional architecture. And I think that will probably be more falling on the wall of XApps and RIC than on the OSS itself, is my feeling.
Okay, I think that's fair. We've kind of danced around this a little bit, right? Where some of the priorities, are in trying to advance O-RAN and get to the level of, stability and maturity that you'd expect out of traditional RAN. If you were, right, emperor or whatever for a day, right, and you could say where you would want to place bets on investment, right, to try to really accelerate, right, O-RAN, to a point where, it ceases to be anything of a challenge. Where would you prioritize, some of those investments in the O-RAN space?
That's a really good one. Okay, difficult question, but I think I would put it in silicon. So in two places specifically, or three, if you may. One is to run layer one, lower layer one for massive MIMO. So if you bring out some silicon, which is what Qualcomm announced a few months ago, and even, already Qualcomm announcing that changed a lot of the landscape and the future of this. Other big companies may follow, but I think having a really healthy, wide offer of silicon that you can embed into, kind of almost white label designs of massive MIMO, I think will speed up the adoption of Open RAN, particularly on that difficult problem. Then on the baseband, I would say two things. One is simply we may do with more options than just the fantastic Intel that we have today. So we may need more competition there, and that's silicon again. And particularly acceleration is very vivid, active, hectic space where we need more people to come and throw their GPUs or ASICs to accelerate processing. I think if I had an unlimited supply of money and I wanted to invest, I would probably put it there.
Okay. Well, and I think that's fair too, especially given what's in the news on microelectronic circuits these days. One of the things you talked about too, though, like looking at the GPUs, right, and the processing right at the edge, where do you see stuff like multi-access edge computing playing a role, right? Again, and coupling that, right, the confluence of XApps and the RIC, right, with MEC and maybe some, AI, some, data analytics right around AI/ML. Do you see any coming in that space?
Yes, yes, I do. For the starter, there are operators that are like more naturally into the kind of cloud RAN space because their, their availability of dark fiber and architecture is particularly favorable for that. So on those cases, there is an intersection between where you may want to put your edge computing resources in the near future and where you're centralizing your CU part of the basement. So I think they're going to be almost, in the same space-time coordinates. So there are some synergies that you may want to exploit, and that is one angle to it. Now, if you fast forward, I don't know, maybe 5 years beyond that point, you will find that you have off-the-shelf hardware, computing hardware, present in every site with a container platform that is pretty much standard. That may have idle capacity where you're running your radio. So guess what? You have edge computing resources, container-based, exactly like 3 milliseconds away from your customer. That may not be a thing today, as there are no applications that require that type of latency. But in the future, I think Open RAN will naturally kind of take you to a point on which you have everything you need, including the operating system, to run applications, not just through the rig, which is super interesting, but also through a mini core network and deployed on site for extremely low latency use cases. So I think that will be a thing, but probably not in the next 5 years.
Right. I mean, it feels like, that's an enabling capability, right, to get to those, ultra reliable, low latency use cases right around industrial automation, maybe, or telemedicine, where those tolerances for performance, right, are an order of magnitude, greater, right, than, we saw in LTE.
You're right.
Now, being tolerant of the time, I think we have 7 minutes left. One of the things that I think would be really valuable for the audience to hear are, what advice would you give, a smaller operator, right, that's looking to deploy O-RAN? What types of challenges would you see, right, in terms of the scale of the operating community versus the types of things they would need to pay attention to when they were deploying O-RAN themselves?
Right. Yeah. Okay. So I guess first one necessarily would be there is a lot of hype, and this area is getting a disproportionate amount of attention for reasons that are probably not related to technology. So I don't want to sound cynical, but don't believe everything you hear. There are some kind of polarized views. There is some people pretending that the technology is absolutely ready and able to take on dense urban areas tomorrow, and it will just perform the same or better than the incumbent architecture. In our experience, that's not the case. That's not true. The technology is fantastic and it's going to come to that point, no doubt, but there is a lot of things that we need to do before it gets to that point. So it's not ready for kind of, take on a big city tomorrow. Equally, on the other extreme, there are also parties saying, well, no, this will never work, or this has some kind of inherent embedded problems and is really a bad idea. I don't think so either. So don't believe everything you said. I think in these cases, I think operators tend to be more neutral, as we're not biased. We're just trying to get the best for our customers. So if it performs and it gives a good customer experience, then it's good enough. If it doesn't, then it's not. So I think going to other operators to retrieve their experiences is probably a more reliable source because it's normally non-biased than talking to other parties in the industry. That would be the first thing. Related to that, I think it's a good idea to join organizations and alliances that are active on this space, be it O-RAN Alliance, if it's more the specification and understanding of the protocols and interfaces that you care about, and if you think that you can contribute to that, or TIP, if it's more system level specification that are interested, or the Open RAN Policy Coalition, if it's about regulation, equally. I think that's a good idea. First, because you will find other operators there, both experienced and non-experienced, with with whom you can either join forces, exchange notes, or seek advice. And by the way, within TIP or not, I mean, we're happy to work with whoever. So just reach out and ask for help if you want from Vodafone as well. But I think, simple as it is, that would be my kind of starter for 10.
I like that, right? I mean, I kind of feel like, especially with your role at TIP, we should have a flashing banner at the bottom of the screen for call here for, support services from TIP. I mean, do you see that kind of already, right, within TIP and the Policy Coalition and the O-RAN Alliance, where, operators are building a community of interest where they're sharing lots of information?
Indeed. Absolutely, yes. And I think the three of them, it's true. I mean, I do have a role in TIP. I should have said at the beginning, and I forgot. I'm the chairman of TIP. I'm president. So yes, I have a view on that. However, I don't think this is exclusive of TIP. I think O-RAN Alliance is also doing a very good job, and so is ORPC. It depends on where your primary interest falls, as I said before, in regulation, in interface specification, or in system level kind of specification. Then one or the other may be better for you. But if I speak for TIP, I tell you everything is open and shared. So like, for instance, when outside of all these organizations, the 5 biggest operators in Europe, we got together and we signed a memorandum of understanding in February this year to just signal our determination to do Open RAN in Europe. Part of that memorandum of understanding was to work for us to work together in building a common set of specifications, which we did, and we published them last month. And we chose O-RAN Alliance and TIP to publish those specifications, so they are available there. And if I speak for TIP in this case, as TIP, we're gonna take those specifications and make sure that we build a roadmap so that we maintain them, we do the testing and validation, and we provide like a vendor map so that if you want those specifications, you know where to buy them. So I think that could be very useful for someone who's looking to do some of this and doesn't know how to start, maybe.
All right, I think that's great, right? I mean, because I think the one thing that we do want to get to, right, is moving disinformation to the side, right? Because like you, right, and when we've been exploring, because we're MITRE's building out an O-RAN testbed ourselves, right? There's variance, right, in terms of the level of information, right, that you can get out there, and I think it is all over the map, right, and somewhat polarized. So I do appreciate, right, being able to go to organizations like TIP and the O-RAN Alliance and the Policy Coalition to try to get at some of that. So I think that's fantastic. I think, Brian, I think we're at time, so I feel like I should be turning this back over to you. And thank you again, Iago, for your time today. This has been fun.
My pleasure. Thank you very much.
Yeah, thank you so much, excuse me, Andrew and Santiago. We appreciate hearing from a provider who has made the switch to Open RAN technology and standards, and really hope that your experience can help others as they consider an Open RAN deployment. We're running a little bit ahead of schedule, so let's take our last break before session 6, which starts at 12:50. And we will see you all then. Thanks. Welcome back, everyone. For our final session, I am pleased to present additional Open RAN vendors who offer end-to-end Open RAN solutions. Please note that there will not be an opportunity for panelist interaction or questions and answers, but remote attendees can contact the company or to speak directly to them. We will be posting contact information along with presentations and a copy of the showcase video on the FCC event webpage, which you can find at www.fcc.gov/events and look up either the name or date of the event. Here are these remaining vendors we'll hear from now. Steve Papa, CEO and Chairman of Parallel Wireless, Chip D'Amato, EVP of Inland Cellular, Arda Arkman, Director of Software Engineering at Juniper Networks, John Baker, SVP and Business Development at Mavenir Systems, Ganesh Shankabagaram, Head of Integrated Products and Ecosystems at Radisys, and Azidia Arvani, General Manager of Rakuten Mobile Americas, and also Alok Shah, Vice President, Strategy and Business Development and Marketing at Samsung. For these vendors, the sessions will be 20 minutes long, but I will provide a 5-minute warning. Chip and Steve, please take it away.
Great to be here. Thank you, everyone, for your time and attendance. If I can get the next slide, that would be great. Okay, so quick introduction here to Parallel Wireless. I'll allow Chip to introduce himself. We're very fortunate to have Chip as one of our customers in the United States, deploying Open RAN as we speak. Parallel Wireless has been pioneering this whole idea of opening up the wireless infrastructure with COTS computing for quite some time. We draw our lineage back from the opening up of the data center to COTS computing. We're now present on all the continents with cellular service. particularly emerging markets, particularly lots of rural use cases, where, as we all know, the challenges can be very different than, say, downtown Manhattan. And we're trying to recognize it's not just 5G, but all Gs that are necessary. In the US, it will be mostly 4G and 5G centric, but that's our focus. So that's parallel wireless. I'll allow Chip to introduce himself here.
Thanks, Steve. Glad to be here. It's kind of crazy right now, so if you hear some noises in the back, please excuse me. I'm in a hotel room and we're doing another presentation, and we're at fire camps all over the Northwest right now. If anybody's seen the news about all the fires we've got going, I think we're about 1 million acres right now in our network area. So apologies if anything goes on in the background. So Inland Cellular, regional carrier. We've been for about 30 years, a little over 30 years now. We serve about 39,000 mobile subs in north central Idaho and eastern Washington. We've also diversified into a fixed wireless presentation as well. Our focus and our goals have been on rural America, as you can imagine, in north central Idaho and eastern Washington. And the challenges have been quite large. And every so often, every few years, those challenges get greater and greater. Challenges everywhere from resources, which I think we'll talk about how Open RAN has helped us in that category, to infrastructure costs, to just basically giving service and blended service in areas that are most necessary. And as we migrated into the Open RAN environment, we actually started that kind of concept fairly earlier in the road, based on the fact that when we went to 4G, we looked at some things that were causing some of those challenges. And that was basically being restricted from a core or a switch level. And our goal was to try to find something in that area that was open architecture. And so we had that concept in mind several years ago, that we wanted to do something. We wanted to get involved in open architecture that allowed us to basically have a little more control over our network, and do things that weren't basically manipulated by a third-party vendor or something along those lines. And so that was a challenge that we've overcome, both at the core level as well as we're overcoming at the RAN level. And it's been a huge success for us. It's allowed for more opportunities, quicker to market, and so on and so on. So, and I think we'll discuss that a little bit further in the program, but thanks for having me. And Steve, thanks for asking me to speak here, and hopefully we can give some information.
Great. Can we go to the next slide, please? So, in our work with CHIP, we've, it's gotten some visibility at the national level, in particular in the Washington Post. It did a fairly extensive write-up on the work. And, the challenges that CHIP's facing in Idaho are similar to many of the challenges being faced across the rest of the country, right? Serving, I'd say, the more economically marginal parts of the network that the large operators aren't covering. So Chip, if you want to, I don't know if there's anything else you want to cover on this slide, would be great.
Yeah. So, one of the things that, as in the first paragraph here, the first bullet point, price or cost was kind of a big deal, right? And that cost has multiple tentacles to it, right? Actual cost there, but also resources and time to market. With limited spectrum, in some areas, which a lot of regional carriers have and rural carriers have, it's more important for us to add more sites, cell splitting and so forth. But it's also really crucial that we get into rural America. And when I talk about rural America, I'm talking about rural America, right? Not the outskirts of New York City or California. And right now is a perfect example. In my opening remarks, I commented about the fires. We have 24 fires burning. We are visiting right now in the last couple of days, 6 different fire camps of over 300 people each. And we are the only carrier really covering that. Now, there are some other carriers, national carriers that are roaming on us, but I think that gets lost in the shuffle. For us to be able to expand out into these rural markets, and there's lots of them, right? I laugh sometimes because I came from a big city, 35 years ago, and I look at them and go, yeah, but there's one here and there's one there and there's one there, and these all got through 3,000, 4,000 people, and they're just as important as anybody else. For us to expand out in those marketplaces and give that coverage, and right now we're looking at infrastructure bills and broadband bills and everything of billions of dollars that, we're saying, God, it's really important to give people coverage. Well, the only way we could give that coverage was to reduce our cost and find other tools in that toolbox that were going to allow us to do that. I don't want to go on record saying that, Open RAN is the greatest thing, is the only way to go. What I would say is that Open RAN has allowed us to be able to make those basically make those expansions, and also within our internal network in the less rural market, be able to cell split to our spectrum holdings to give service that is needed in those areas. Every network's a little bit different, and rural American networks are definitely different. And there's nobody that really knows those networks except for those carriers. And it's important to us because those customers and those people at those fire camps this week, and those people that live in those communities that are in danger, are our neighbors, right? They're those people that we have to give service to, and we take that really seriously. And we couldn't do that without operating the network that we knew the best way to operate that network was. And after testing and doing some things and so forth, we found that Open RAN was absolutely, and Parallel Wireless was absolutely a great solution for us based on our needs. There may be another company there that doesn't, necessarily need that same type of infrastructure, but it's a choice, and we have to be able to make choices based on what our needs are for our customers, our market area, our network. So the ability to cut costs, both at the cap level as well as the resource level, for simplicity and the way it's all designed and architecture wise, was a huge advance for us, and able to start building out a lot quicker than anticipated. We probably cut our build out to a lot of these areas by about 24 months based on the savings in cap as well as the simplicity and the technology there. So we were pretty excited about that. Granted, there were some little hiccups in there, but I think any time there's some hiccups, you do anything new to your network, you're going to have some hiccups. They weren't major hiccups, right? I mean, this article here in the Washington Post, I made a comment in there. Hey, we're out on our own. We're in a little corner in inland Northwest up here. I don't have time to get involved with government regulations and a lot of this other stuff. We don't have the people, the amount of resources to do it. And so it was really important for us to get involved with something. And I keep hearing all of these comments about, well, it's unproven, it's unproven, it's unproven. Well, we just went out and proved it. We didn't get caught up in a lot of that. We decided we were going to go take this challenge on ourselves, and let's get some e-nodes and some radios in, and the gateway in, and let's test it against our own network and see what's happening and see how it functions. We were incredibly surprised at how well it cooperated and how well the throughput, we were getting higher throughputs and so forth. So we did our own testing, right? We kind of did it in the field, put it to the fire, and it succeeded, and we're extremely pleased with the direction we're going now. Those hiccups are minor. The other opportunity we had too was that in previous infrastructure, we were limited to different, whether it was different releases or different functionality in there, or different services that we wanted to have on or have off, right? And again, every network has its own challenges. Every market has its own challenges, has its own needs. And in our Open RAN environment, our Open Core environment, we are much quicker to market with those needs of our customers in our area. And we're not hamstrung or we're not tied to it. We don't have to say, hey, listen, we have to budget for that next year because it's going to cost us $40,000 to turn that SOC option on. We can go in and manage our own network a little more remotely and a little bit more in our own terms. And we have the choice to do that. And I think that's really important that, you know, every carrier makes that choice and has that opportunity to manage their own network a little bit more independently.
Well, Chip, thanks for that. I think you exemplify the can-do spirit that is so essential for Open RAN, which is we're just going to make this happen. If the next slide can go, please. Just at a high level, many of you will have seen this. Open RAN sort of is your familiar radio heads. We have what we call a virtual BBU, which replaces the traditional proprietary baseband units. But you'll see many of the things are very familiar, okay? We try to make the software as plug and play as possible. We have a controller that just abstracts away a lot of the complexity, which in a longer conversation we can go through. But the main message here, it's real, it's today. It's not some hypothetical, concept. Next slide, please. As you know, the U.S. band plan is a little different than a lot of other countries. We're working hard to serve what I would call the traditional spectrum here in the United States in time for what all of the operators need in January of next year, and working with millimeter wave options by the end of next year. So if you can go to that next build here, please. We were asked by the FCC to make very clear what is orderable on January 22nd. And, we fully expect for any 2x2 or 4x4 band that is common here in the United States, you will be able to order. The software for 4G and 5G will be there. The real-time controller that you're seeing as part of the O-RAN standard, as well as the appropriate EMS. The exception for us will be millimeter wave late in the year as an access technology. Of course, we're compliant with any millimeter wave backhaul technology. Next slide, please. It's really important to understand that the number one thing that created Open RAN was the idea that the proprietary interface between what's at the top of the tower and what's at the bottom creates a chokehold for the vendor. Okay. And, in my experience talking to Chip, it's very real. The leverage that an incumbent vendor has because of the cost of a tower climb to change all that equipment. And so the number one thing you want with Open RAN is that interface is open. You're able to use different radios down the road or different basebands should you so choose. Because without that, the balance of power it's not a competitive market for the operator. Okay, it's a captive market. And that's what Open RAN's trying to fix. There's a lot of other good things that come with Open RAN around virtualized software and all these other things, but you need that open interoperable interface so that you get to choose as an operator where you go in the future. Okay. Next slide, please. I'll pass this on that's my lead in for you here, Chip.
I think I might have already discussed some of this stuff. I get ahead of myself sometimes, Steve. Yeah, I think that, again, I did talk about some of this stuff. And, one of the things I left out there, too, as you were alluding to there, is that it does create competition and competition within the RAN vendors, that we have the option to do different things, which I think is a huge leverage and advantage into, making the next steps, right? I've kind of talked a little bit in previous conversations about the fact that we keep talking about making the next step in the United States towards advanced technology.
5-minute one.
And as we make these steps towards advanced technology, it seems like we get knocked down a little bit. This is an advance. This is an advance in technology. We control the topology, right? We can upgrade when we get the opportunity. There's many more services available. But the key is, why are we, I think we're advancing in technology, and that's one of the things that we're attempting to do in the United States. And this is, for us anyways, was a huge advance and gave us the opportunity to manage based on the needs of our markets.
So the next slide, please. So if when we think about what openness does, it gives control, okay, to the customer. That ultimately brings to bear market forces. And in my conversations with Chip, we talked a lot about how his context is different than someone else's. The one thing he wants is for us to not dictate to him what he upgrades when, right? Of course, there are going to be some things that, some new capability requires it, et cetera. But he doesn't want us gaming systems to force him to upgrade, to force obsolescence, to force, who knows what, to limit interoperability. He wants an ability to navigate anywhere he goes, okay? Because his problems are different. And Chip put it in his words, that also applies to the choices he gets to make on his network. When he thinks of what the government can do for him, it's how can he facilitate market forces operating across vendors, right? Anything that can be done to help Open RAN become a thriving competitive marketplace is very helpful for Chip. Things that dictate what Chip does, probably not helpful. I'll let you, build on that, and we're pretty much out of time.
Yeah, I think we're close to that time there, but you hit that on the head. I think we both said it in different words there a little bit, Steve, is that, that control and being able to do things at a quicker to market pace and in several different methods, right? One being capital expense, obviously. The second being, resource management because of simplicity and lack of tower climbs, but getting things remotely done or at the ground level. Being able to do things a little bit more efficiently at initiation levels and so forth. It's really allowed us to be a little bit more free, if you will, in giving services and so forth to customers. And you're right, I've been kind of a little bit of a critic on some of the government side of things, basically dictating what and when we have to do things. And we all know there are things that carriers, and especially regional carriers, that are pretty resource limited, but are giving vital services to areas that tier one carriers might not even know are there, right? So it's much more difficult to serve those areas. And so we continue to get more legislation and more things put in there that we have to do from the government level. And in a restrictive level, what we're seeing is Open RAN also allows us to be a little bit more free in opening those things up and moving in that direction to some of those categories as well.
So to wrap it up, Open RAN is real. Open RAN is making a difference in the lives of Americans today, as Chip described. And Open RAN holds the potential to bring more agility to operators like Chip, to bring more coverage and make a difference in the lives of more Americans, right? The openness is the key to dealing with these very challenging economic circumstances of connecting the remaining Americans. With that, I think we've said what we had to say, Chip.
We can say a lot more, but I think we're out of time, Steve.
Yeah, thanks, Steve and Chip. We appreciate that presentation. And next, we're going to turn to Arda Arkman, the Director of Software Engineering at Juniper Networks. Arda, whenever you're ready.
Hello, everyone. Thanks for the opportunity to present what we are doing in O-RAN, and thanks for the great presentation to Steve and Chip. What I'd like to focus today is what we are building in O-RAN, and being a RAN neutral vendor, not a traditional RAN vendor, Juniper, how we are adding value to O-RAN and other solutions that we are working on. Next slide, please. So many of the participants are presenting the value of ORAN, what it brings to the network, what it brings to operators. And we think the three key aspects of ORAN are critical, and our approach to unlocking the true potential of ORAN relies on those three aspects. Coming up with innovative use cases, so the new business models, personalized service experience can help operators make additional revenue while optimizing their CapEx and OpEx. Having automation and control in the network through near real-time RIC, non-real-time RIC, as well as the SMO, which I'll briefly talk about in the next slides. And the ecosystem, whether it is the interfaces, the platform, whatever we call in this ecosystem that is being open, so we can have a truly multi-vendor, no lock-in on hardware, software platform to be deployed. Next slide, please. We think to deliver the services required by operators, whether it is a large operator, a regional operator, as we have seen in the previous presentation, there is network slicing, which is a foundational 5G objective. In 4G and earlier networks, we have one-size-fits-all network approach where it isn't sufficient to support the variety of services that are required, whether it is higher throughputs, lower latencies, number of devices, whatever the service type is. With 5G, the concept of network slicing is introduced, and along with network slicing, there are a number of challenges to be solved. How we orchestrate, how we manage this network so we can easily deploy services by creating end-to-end virtual networks that can satisfy the service requirements. Next slide, please. And our solution, our approach to this problem is to introduce an orchestration built on ORAN vision with slicing is the first class design. Our network service orchestration can support multiple clouds, whether you have an edge cloud, regional cloud, national data center, or even a public cloud, so that the operator itself or the MVNOs and the enterprises using the service from operator can deploy slices that can support different service requirements. It's truly multi-tenant, multi-domain, where each tenant can manage their slice and create slices within their slices. All of this through the provider managed operator. Next slide, please. Looking deeper into our network slicing and orchestration architecture, we are building an SMO. And in the following slides, I'll focus more on the Open RAN domain, the left-hand side, the left bottom side, the RAN domain. But there are challenges that need to be solved to deploy Open RAN and manage it when you look at the scale. Of course, within ORAN, there is new components, non-real-time RIC, near real-time RIC, to insert intelligence to the network, and also OCloud and other components to support the virtualized deployment of those services. But network is an end-to-end service. There is RAN, there is core and transport network to connect those two. Juniper, being a transport network company, has very strong, very sophisticated transport network solutions, and recently has been investing in RAN domain through acquisitions. And one of the companies Juniper have acquired is Netsia, which have been building non-real-time RIC and near real-time RIC even before they were called RIC for the last 5 years. Through this orchestration architecture, an operator or an MVNO or an enterprise can easily deploy a service where everything is automated. RAN service can be created, core service can be created, and these services are stitched through the transport network connections. All of this can support multi-cloud infrastructure where the RU, DU, CU, the core network can be deployed in wherever the clouds are available and whatever the service requirements call for. If it is low latency, these network functions would be closer to each other, so minimize the transport network delays. But if it is an eMBB service, we can place some of these functions in the central network for better cost savings and resource pooling. Next slide, please. So what do we do in ORAN? Anything you see in the slide, anything in green is what we are focusing on. We are not a RAN vendor, so we are not working on an RU, DU, CU. We are partnering with RAN vendors. And within these components, we are focusing on fully open interfaces such that any of these green components are like Lego pieces where you can plug and play either our solutions or third-party solutions. That is the beauty of OpenRAN, and we fully support these concepts where you can take our non-real-time rig, combine it with any vendor's near real-time rig. You can take our slicing management functions combined with other OCloud management orchestration functions, whatever the combination that you would like to do. We are very active in ORAN. In the next slide, I will talk about our activities. We have support for ORAN compliant front-haul transport network solutions. In terms of cloud architecture, we have very strong CN2 container network interface and the underlay required for the data center. And of course, our focus area is non-real-time rig and near real-time rig to introduce intelligence into the network. And all of this, combined with our service management orchestration, helps operators to automate, control, and deploy networks with a single glass of pane. Next slide, please. We are very, very active in ORAN. I'm chairing slicing task group and co-chair of use case task group. We are editors in number of specs for non-real-time rig and near real-time rig along with interfaces. We are making significant contributions to various working groups, working group 9, especially on transport side, security focus group, cloudification, open interfaces, working group 5. And along with OpenRAN, ORAN Alliance, we are also active in TIP, GSMA, HC, and other organizations who are driving OpenRAN initiatives. Next slide, please. Without going into all of the details, this is a high-level diagram of our non-real-time rig architecture. Our non-real-time rig is containerized microservices-based framework where it is highly scalable, and we are able to deploy any third-party RApps as long as ORAN compliant. We are not mandating our rig to run just Juniper applications, but our goal, as I mentioned earlier, is to be fully open, fully multi-vendor interoperable, and we would like to onboard any third-party application that is compliant to specifications. We have an application manager to onboard these, a number of interfaces towards the service management and orchestration so that we can introduce AAML plus features. And for that, we have a very strong AAML framework called Marvis AAML. This is another product, another area that Juniper have invested in, a Wi-Fi solution, and has proven itself in the network deployments, reducing the number of issues and the number of calls significantly, and we are utilizing the same AML framework in our rig architecture. We also have the slice management functions, the network slice management function, NSMF, and the sub-slice network management function, so that we can create, manage, and configure slices as required by the services. The non-real-time rig communicates to near real-time rig through ORAN specified interfaces, and it can interoperate with other SMOs. The SMO does not have to be Juniper. It can operate with open source SMOs like ONAP or other third-party commercial solutions. Next slide, please. Our near real-time rig architecture is also containerized microservices, so it's highly scalable, reliable, And we have an application manager to onboard the applications, number of features so that the applications can communicate with the non-real-time rig through A1 interface, to CUs and DUs through E2 interface, and configuration, performance, alarms, the FCAPS interface through O1. There is a high-speed, low-latency message router so that applications can utilize the near real-time rig services such that any application can be onboarded, managed, and deactivated through the SMO. This is an area we are focusing on where everything is very efficient so that we are not adding any complexity in terms of compute power or memory requirements on the network, but rather making it very efficient and easy to deploy, easy to manage system. Again, the goal is to support third-party applications. We know innovation is going to happen across the industry, and this we'd like to nurture so there are more companies working on XApps, and we'd like to onboard any XApp, any third-party XApp that is compliant to ORAN specifications. Next slide, please. Here, I'd like to talk about one of our use cases that we have already implemented and demonstrated in Tier 1 operators, the RAN sliced SLA assurance use case. When an operator deploys a network slice, or when an enterprise requires a network slice from an operator, generally there are some SLAs, whether it is throughput, so much throughput for the slice, latency, so much latency for the slice, or there could be other requirements such as the slice should not use more than such and such number of users or sessions. Our sliced SLA assurance use case continuously monitors the network, the CU and DU especially, by getting the performance metrics. And as we detect SLA violations and any possibility of future SLA violations through our AI/ML prediction algorithms, we are taking corrective action. The first corrective action is from non-real-time rig to set the policies, maybe redistribute resources, maybe limit the resource usage, or maybe in cases provide more resources to a slice that is suffering from lack of performance or whatever the requirement is. And the near real-time and non-real-time work in conjunction to enforce these policies through E2 interfaces on CUs and DUs. We have been building significant IPR in this area. We have over 20 plus patents granted in slicing, and we have deployed the POCs in more than 5 Tier 1 operators across the world, and this is all through Open RAN initiative. Next slide, please. Along with slicing, we are making progress on a number of use cases. Here you see RAN slice assurance and tenant slice aware admission control in blue. Those are the ones that we already have demonstrated in operators and continue to deploy as POCs. Along with those, we are working on other use cases, whether it is optimizing the QoE of users, balancing the network through traffic steering, and we also have new use cases that are not described elsewhere, such as integration of MEC, multi-access edge computing, and ORAN, and unified slice management, managing more than just RAN slices itself. Of course, energy efficiency is critical for operators. We see significant interest, and we are building energy efficient applications. And we have integrated some of these use cases with major DU/CU vendors. We have ongoing rig trials with Tier 1 European service providers.
5-minute warning.
And we have key IPR related to rig, XApps, and slicing. And we continue to build on those areas. Next slide, please. So this is my final slide. This is our end-to-end ORAN architecture. Juniper being a very strong transport company, as you can imagine, we have excellent solutions for far edge data centers, edge, regional, central, ranging from 10 gig to 100 gig to n times 100 gig and 400 gig. Number of Paragon solutions to optimize the transport network, to control the transport network. And through the addition of non-real-time RIC, slice management functions, now we can work with any RAN vendor and deploy an end-to-end network through a single glass of pane and help operators lower their cost, manage their network, and introduce intelligence and use cases through O-RAN architecture and other Open RAN initiatives. Thank you very much for the opportunity. I'll be very happy to discuss further details.
Thank you so much, Arda. And now we're going to turn to John Baker, the SVP of Business Development at Mavenir. John, whenever you're ready.
Yeah, thanks very much, and it's great to be here, and many thanks to the FCC for arranging a great informative session on Open RAN. I'm John Baker, Business Development at Mavenir. I'm also on the board of the Open RAN Policy Coalition, and Mavenir, participates strongly in TIP and O-RAN Alliance. So we've been one of the early collaborators and participants in the O-RAN Alliance. Next slide, please. So, we're really coming from the fact that we're really building the future of telecommunication networks with cloud-native software. Mavenir has really started the virtualization and the softwareization of products back 10, 15 years ago, and now moving into the virtualization of networks for 5G. We're all about embracing disruptive and innovative technology and disruptive business models, and really allowing the operators to look at new solutions that allow them to become profitable, protect revenue, and reduce costs. And lastly, how we then add analytics and artificial intelligence sort of across the network. Next slide. So who is Mavenir? I think Mavenir is a $500 million company, really breaking into the software space. We're serving 250 mobile operators worldwide across 120 countries. So I think it's fair to say that most people's messaging, call processing, and will go across a Mavenir element somewhere in the world. So we're very, very focused at deploying mobile networks. We have over 500 million small cells deployed here in the United States alone. And so, we've got significant radio and cloud expertise in terms of the acquisitions that Mavenir has made. Next slide, please. Given the time they've got available, I'm really going to sort of focus on the products that are available here today, as per the request of the FCC. And our solutions are really sort of positioned at all market segments of macro, enterprise, and private networks. And when we talk about end-to-end, it really is from PSTN to the cell tower. And for various operators as well, it includes the apps that actually go on the mobile phone. Next, could you just jump 2 slides, please? So when you look at the network and the vision of the future, really the network is all software. Sadly, the radio technology is not at the point yet where it's a general processor. So that's the only hardware piece of the network. And Mavenir is developing radios in certain niche areas, and I'll come on to that in future slides. But in reality, it's building a cloud-native platform that allows, a low total cost of ownership. It's flexible in terms of its scalability. So, with softwareized platforms, you can build a platform that will support, a few subscribers at one end, and then, have that running on a small compute platform, and then, scale that up to hundreds of millions of subscribers, supporting, just IMS platforms like we do here in the United States. So, and then on those platforms, you can mix and match the virtual elements that essentially like packet core, IMS, video voice processing. But in a sense, from a hardware perspective, it's completely disaggregated from the software, and you've got that scalability and flexibility. And as we heard earlier from Stephen Bai and AWS, we actually have the products in the cloud today, supporting all of the network functionality. Next slide, please. So Mavenir's portfolio is, and these products are all available today. So, that's the important part. From the left-hand side there, we have the core products in terms of multimedia messaging, IMS, voice video. In the middle there, we do applications that operators have on mobile phones. We're a strong believer in mobile convergence, and we do participate in the CableLabs convergence initiative, and also supply the business tools that sort of go around that. On the radio side, with the Air products, we supply the RAN, mobile edge computing, and then edge products like CBRS and private networks and small cells. But essentially, all of this technology is running on cloud native based platform architectures. So the integration layer, would be OpenStack, Kubernetes, but we consider ourselves one of the only end-to-end network software providers for the mobile industry. Next slide, please. So I'll briefly cut through some of these slides. In terms of the products that are available today, we have virtualized packet core, actually carrying some of the largest traffic in the world, fully virtualized with in India, we're carrying like 1.8 terabits per second, and in 18 different locations. So the platform is truly scalable, truly reliable, and supporting 2G, 3G, 4G, 5G technology. So not only are we looking after the future generation technologies, we're also supporting the legacy technologies where necessary to allow the transition from proprietary networks to open networks. Next slide, please. On the IMS side, we're a leader in the world supply of IMSs. We have 39% global market share, and I think it's fair to say in the US, pretty much majority of the calls will go across a Mavenir IMS for 4G. 5G is looking, how to deploy, the IMS platforms in there as well. But you can see some significant logos in terms of T-Mobile, Deutsche Telekom. We're proud to be a supplier of Dish in their build of the new 5G Open RAN network, Rakuten and Telefonica. So again, proven that virtualization exists, it works, it's real, it's secure, and it's scalable. Next slide, please. So really focusing now on the Open RAN part of Mavenir's business. And Mavenir really started this journey, based on its Open Infrastructure Technology platform about 5 years ago. But today, now we have the world's first fully containerized Open RAN, so split 7.2 open interface virtualized platform in the marketplace. So with RUs, CUs, and DUs. You see some of the logos down the bottom here where we have commercial deployments and trials already underway. So as Steve Papa said, Open RAN is real, and I'll show you some of the results that have come out of that at the end of this. But we've got live networks with Axiata. We've also significantly when we talk about the frequency bands, we've got Open RAN at sub-6 frequencies right down 700 megahertz, but we've also got this at 28 gigahertz running Open RAN microwave technology, and I'll come on to the radios about that in a minute. But we've really focused with Vodafone in terms of the deployment in the UK and Africa, and the Sonic Labs have just been announced in the UK as UK test beds for proving Open RAN interoperability. And the one thing I would really say about Open RAN, when people talk about Open RAN, unless you can demonstrate interoperability and open specifications, you don't have Open RAN. And this really comes back to some of the FUD that's in the marketplace. People claim they have things, and performance-wise, like Steve said, Santiago said, that you really need to get the facts. And there's a lot of misinformation in the marketplace about the performance and the technology and some of the influences of Open RAN. Next slide, please. And last but not least, we've spending a lot of design effort and technical effort on building AI and analytics into these platforms. Mavenir has analytics across all the platforms, and we will have the first fully O-RAN compliant RIC platform going into service. So, we very much focus as Mavenir on open interfaces, interoperability, and the whole thing about the Open RAN marketplace. It's about co-opetition, where vendors will cooperate to prove products and then compete in the marketplace to actually win customers and win business. So, it's a very dynamic marketplace, but and I think I've always really spoken about the fact that the App Store, based on a RIC platform, is the future of mobile networks, where cost savings, optimization, et cetera, are really going to come off the RIC platform. Next slide, please. As Amazon and Dish have spoken, we've got the web-scale platform, and so really there, you've got many of the hyperscalers where you can actually run this platform on, as was talked earlier, that you can deploy in different types of data center, right from the edge right to the core, and just leverage the data centers as and when you need them. And you can see the vision of the future where usage will be by you can actually negotiate a price to use the network at some point in time. So you're going to see network pricing or resource pricing based on availability and times of day even. So business models for mobile operators are truly going to change because of cloud deployments and the use of the RIC and artificial intelligence. Next slide, please. So I talk about the, unless you've got interoperability, you don't have Open RAN. And if I work from top to bottom on this slide, you'll see the partners that Mavenir has been working with. We were one of the first companies out of the gate with true Open RAN interface product. All of the deployments we've made today are based on Open RAN interfaces. And you see that from a radio perspective, we have multiple radio suppliers. Xilinx talked about the massive MIMO product that we're launching at the end of the year as a partnership with Xilinx. So, the great thing about Open RAN is that, you've got vendor choice. The early challenges is the interpretation of the specifications. So it's really been about vendors working together, prove the products, bring them to market, and then compete in the marketplace. And to that extent, then the operators can purchase directly from any of these vendors. They don't have to come through Mavenir. They don't have to, there's no markup going on. There's no margin stacking going on as is in the existing ecosystem. So, really lowering the cost to the mobile operator in terms of building the network. In terms of CUDU platforms and software, you see the list of names here in terms of the key names such as Dell, Intel, Kontron, Xilinx, all very strong partners, all developing new solutions, and things like Stilcom and NVIDIA building accelerator cards to again lower the cost. And by using data center type solutions for building Open RAN networks, really allows to get the cost benefits and the pooling benefits that are needed to really truly lower the cost of operating a mobile network and get some profitability back into mobile operators. And then from a cloud perspective, we're working across the AWS, we've got software from VMware, Red Hat, Wind River, and even Mavenir's own cloud platform software as well. Next slide, please. So we talk about radios, and obviously the requirement from the FCC was about what's available 2022. So we've got radios now that we've developed for sub-6 for the US market. Sadly, when we embarked on the venture, that US radio manufacturers had pretty much disappeared, leaving the proprietary vendors to control the marketplace. Mavenir has invested significantly in building with partners a radio selection for the US market, and a lot of these radios are available today. We've got other radios coming on for the end of the year. They're going through the finalization of production in the US and going through the necessary FCC approvals. You'll also see in this list that we have millimeter wave product that is to an O-RAN architecture. So again, using this architecture for the different frequency bands, and I think it's fair to say that the O-RAN architecture is frequency agnostic. So, on the assumption of the processing power and the necessary accelerator cards, then you can support everything from 500 megahertz up to tens of gigahertz. And then, last but not least here, and the one anomaly on this slide is the Massive MIMO product that's in Q1 next year. We've launched Massive MIMO product with Deutsche Telekom last week, really proving that, again, the misinformation that was in the marketplace, you can support Massive MIMO on Open RAN architectures, and there's a full Massive MIMO portfolio following on from that. Next slide, please.
5 minute warning.
Now, this slide is significant. And again, this was an adaptation of a slide that was presented by Nokia last week. The first 4 columns, came from a presentation that Nokia made at the Rural Wireless Association about the cost of building mobile networks for the rural markets. And to that extent, these pricing information comes from the FCC pricing catalog version 1, of which there was an error in there around the Open RAN pricing. So we've added the Open RAN pricing in that last column, and you'll see some highlights there in green where there's significant cost reductions by using Open RAN solutions. I think the one comment that I would make, that through Open RAN, pricing models are going to change significantly from a software feature and functionality perspective. We expect that software features and functionality, such as paying for radios, paying for power levels, paying for all the different features that are in a radio, is actually going to disappear. This archaic method of paying for functions on a radio is really a burden to mobile operators. So we see that going away with software-based solutions, and again, resulting in significant cost savings for mobile carriers. What I've also done is added an OPEX line in here as well, because it's not just about the CapEx. It's really, what is the total TCO of a mobile network going forward? Mavenir really is from out of the gate, has really been saying that, it's about a 37% TCO for a mobile network. And, without doing any hard work, and you can take these numbers from the next version of the price catalog that get published by the FCC. You can calculate a 36% average TCO between conventional network technology and Open RAN solutions. So significant savings to be had. I think all the predictions that we're seeing on a worldwide basis are coming out. Rakuten, 40% CapEx. Here you've got 40% CapEx savings, 36% TCO. So, the promises from the Open RAN will bring the savings are true and are there to be reaped. Next slide, please. One thing that was talked about, and I think this is a slide again where, facts speak louder than words. The overall performance of a virtualized RAN is being shown to be equal or better in most cases than closed RAN. And I'll just explain this slide. If you take the KPIs that are being measured in the mobile networks, the first 2 columns are the targets that are giving in RFIs, and the second two columns are actually real live measurements. And these measurements, although we can't disclose which operators are coming from, these are actually aggregated across many of our networks and trials that we have out there. So again, from a factual perspective, it really is that Open RAN performance is equal to the closed RAN networks, because in reality, all you've done is change the interface and virtualize the core, virtualize the RAN. But again, the one thing I would say about Open RAN, and keep restating it, is that get the facts, ask the operators ask the vendors for the facts, prove interoperability, and then see where you go from there. Next slide, please. The other main performance area which needs to be carefully taken into consideration is load testing, and the systems need to be load tested and proven to be load tested as part of the proving process of buying into Open RAN systems. Next slide, please. And last but not least, Mavenir offers an end-to-end system integration. We've been doing that for the last 5-10 years with IMS systems, etc. But we've also got strong partnerships with companies like Dell, Infosys, Goodman Networks, etc., NEC. The great thing about this Open RAN technology is that new system integrators can bring this together, and you can instantiate the network very, very quickly through software. So all of the capabilities are there from January 1, 2022 to build these networks. Next slide, please. So really, again, just to restate, it is here today. It's available. I've never seen such innovation and enthusiasm back in the mobile space that I've seen in the last 35 years. So it's the operator and the technical industry's choice now to really enhance and encompass innovation and really take the mobile technology into the 22nd, 23rd century, essentially, to really get the benefits of it. Thank you very much.
Thanks, John. And now we're going to hear from Ganesh Chengabagaram, the head of integrated products and ecosystems at Radisys. And Ganesh, I understand you have slides and a video. Where would you like us to start?
Correct. Yeah. So we'll start with the slides, please. Yeah. Are you able to hear me? Thank you, and thank you, FCC, for this opportunity, and thank you all who are presenting and attending the sessions for the last 2 days. This is from Radisys. If you can please go to the next slide. We would like to give you a quick introduction of the company and our focus on Open RAN and the way we've been interacting with the Open RAN ecosystem. What are we enabling, and what is our approach to Open RAN, especially 5G? Our system integration capabilities, and how do we see this Open RAN space evolve, and how it's going to drive the evolution into 6G eventually, the future of our mobile networks. So that's the kind of focus we've given in this session. If you can, please go to the next slide, please. Yeah, about Radisys. Radisys has been a US-based company for more than 3 decades now. We are headquartered in Hillsboro, United States, in Oregon. And we have been a company which has gone through a lot of transformation, especially adopting many open principles. And we have a wide-ranging set of products available in the market today, starting with the devices, which I want to talk about, the devices, the low-end smartphone devices, and the smart home gateways, which we've been launching. And the smart home gateway and the devices have been launched in market focus of Africa and Latin America. And that is something that we did recently. And we have a huge focus on the disaggregated access, both in wireline and wireless. And when we talk about wireline quickly, we have a disaggregated software-defined PON solution, which runs on Whitebox OLT. This is targeted for both large operators and small rural operators based in the US and other regions in Europe as well. We've been able to successfully demonstrate and do the trial of our solution. And one of our longest running, widely deployed products is our communication portfolio or communication platform and the media server, this node will, these set of products, they provide the voice over LTE and conferencing and media services, media processing related applications support. So this is a very widely deployed product portfolio, deployed in more than 150 operators and touching more than 1.7 billion subscribers. We are deployed in many major networks across different continents, and that is something that we carry as our legacy in terms of deployment support and supporting operators in an open fashion where we integrate and interoperate with other network elements in both the core, voice core, and the IMS network. And we also have a network services arm, and which is focused on the system integration aspects, deployment readiness of network after the system integration, benchmarking, and all the deployment readiness services is being provided by this group. So what we've gone through as a transformation, we are now a fully owned subsidiary of Jio Platforms Limited. Jio Platforms Limited is a company in which Reliance Jio in India is a partner, is a owner, and the other investors include Google, Facebook, and Intel and Qualcomm. Together, these companies have invested more than $20 billion in the last year alone to make the success of this group, Jio Platforms Limited, as a complete end-to-end service provider, helping all the operators across the globe become a digital experience provider from being an ordinary telco. So that's our focus. We'll quickly touch upon the Open RAN part. If you please go to the next slide. So we have been heavily focused on the open telecom solutions for a long time, and we've been a member of the Small Cell Forum since 2007, and we've been leading the 5G and FAPI standardization there, and we've been awarded for our Open RAN contributions in both year 2020 and 2021. We continue to contribute heavily there. We've been a member since the start of Telecom Infrastructure Project. We were named the RAN system integrator in the TIP projects. We executed projects in Menlo Park and different labs, and now we are participating in the 5G Open RAN community. In O-RAN Alliance, we have been having a history of contribution. We were one of the contributors in the XRAN controller interface in the XRAN organization. When that became O-RAN Alliance, we got merged into the O-RAN Alliance, and we are co-chairing O-RAN Working Group 5, Working Group A, where I am the co-chair representing Redisys. And we are also making many key contributions in Working Group 3, which is focused on the near real-time RIC architecture, where we are contributing to the service models, E2 AP, E2 interface definitions. We're contributing in WG5, which is about open interfaces, and we are also contributing in the test and interoperability focus group, where we are making test specification contributions, and we are also leading our open source project over there in open source community of O-RAN. So with all these contributions, we see a wide participation from our side, opportunities to interact with the rest of the ecosystem players and understand how we can promote the applicability and deployment of Open RAN in multiple different deployment use cases and scenarios. And with that background, I would like to quickly talk about Open Network Foundation, where we've been a long-time member since its inception. And we have delivered multiple projects based on the CORD architecture of ONF, but most recently, we've been a founder member of the Software-Defined RAN initiative of ONF, where our focus is to work with the community of our ecosystem partners to develop near real-time RIC-based XApps and the call models for that, and integrating them with our RAN software, CU and DU. We are right now in the process of doing the final integration in an operator lab, where we'll be able to showcase the multi-vendor interoperability of RIC and XApps with our CU and DU, all done over the air in a commercial spectrum. And this will be done in an operator lab very soon, and there will be a press release to that effect. So with all these wide contributions and leadership in standardization, we continue to push for the best of innovation to happen, being part of Open RAN Policy Coalition in the US, and we are also part of the NextG Alliance. We'll talk about it a little later in the slides. If you look at our history, we have been promoting and adopting open platforms, open architectures, and open integration. How exactly we do that is covered in the next slide. If you can go to the next slide, please. So we have been doing multiple projects and licensing our software. Ours is a software-centric story, and We have been enabling a whole lot of ecosystem from the Open RAN point of view. A 4G OEM doing rural deployments today, our software is powering them, and the 4G and 5G OEM deploying globally, our software is behind that, and 4G and 5G vRAN OEM deploying globally, that's also being powered by our software our protocol software in the backend. Right. And we have a history of supporting multiple small cell solutions, and our software is powering more than 50% small cells. And we are very glad to note that in 5G, we have taken a leading space already, and we are supporting and designing into the 5G millimeter wave and sub-6 solutions, which are coming out in 2021 and 2022. Not only that, and we have been addressing the adjacent spaces of public safety and satellite-based communication. We have been a leading software provider for OEMs in US, Canada, and UK. In addition to these things, we have been enabling a good number of test and measurement players based out of US. And we are also engaged in some of the telco initiatives of innovative solutions based on O-RAN, both in LTE and 5G. This is our history of how we have enabled multiple players, and we would like to proudly say that we are the engine behind many of these LTE and RAN products in deployment today. That has been our legacy. If you can go to the next slide, please. The ecosystem partnership part, which I talked about earlier, this is illustrated here how widely integrated and tightly integrated and aligned we are in terms of the entire ecosystem. If you look at all the chipset vendors, we are aligned with all the chipset vendors, integrated. And when I say integrated, these solutions are ready, benchmarked and ready for deployment on these chipsets readily available from us. And it's just not the chipset, the different flavors of 5-layer or the L1 implementation, which is the trickiest part. We have done all the integrations using open interfaces defined by forums like ORAN and Small Cell Forum FAPI. So we have been specialists in that part, and we have integrated across the different ecosystems, and we have focused also on the RU partners, different sort of RU partners supporting different types of spectrum bands and so on. The list is here, a good number of vendors who have started working with us since 2018, 2019. We have integrated and keep upgrading in our integration path with them. So that's the way we enable this market. And if you look at the way we play into the market, finally, we are being enabled by the global ODM partners across the globe. We can partner with any of these global ODM partners to provide a complete hardware integrated solution, with our strength and our focus being on the software side. And that's how we are able to touch a very wide part of the ecosystem of Open RAN today. If you please go to the next slide, please. So this is one quick slide on the proven interoperability of our software. You can see the multiple examples of the RUs, which we already talked about. And we are focused on making sure that our software is interoperable with all the commercial handsets that are available today, both non-standalone and standalone UEs, different modem chipsets. We have covered them all. Test equipment benchmarking happens on an everyday basis in our lab with all the leading test vendors. And we also taken care to interoperate with all the leading core network implementations, focusing on the SA and NSA aspects, both for data, mobility, voice over NR scenarios. And we continue to participate actively in the PlugFest events. When I say PlugFest events, these are the ORAN interop events. The first PlugFest edition, we participated and showcased our 5G SA end-to-end interoperability. In the second edition of the ORAN PlugFest, we participated in the DT Berlin Lab. This was a co-branded TIP and ORAN PlugFest. And we again demonstrated 5G SA end-to-end interoperability, also our DU front-haul interoperability. So this remains our main focus. And the question being raised about Open RAN solution being interoperable, we want to make sure that this is completely interoperable from our end. We just take extreme care on that. If you can go to the next slide, please. So if we are to summarize our offering in one slide, this would be that. And this software, many of these components are already being tested and benchmarked in the labs, both in our labs, our customer labs, and some of the operator labs. And in the ones which are shown in dark purple is our offering, CU, DU, and Open Frontal Gateway. In some places, we have the partner coming up with the hardware story, that is the radio and the small cell. All of these are being made available already to our early lead customers and definitely available for all by the end of the year. And our key partners in this case will be the near real-time and non-real-time partners and players who are in that market, and the ones who are providing the service management and orchestration capabilities. So we've been doing the groundwork since 2019 to do this interoperability, and we showcase this regularly in multiple trade shows and in our labs and our partner labs. So that's the way we want to make sure that our solution remains deployable and interoperable from a Radisys and Radisys Plus partner point of view. If you please go to the next slide, there are more details of how we are making this possible. And since our focus is extremely on the software side, we make our solution ultra flexible and ultra scalable from a RAN software point of view. And from when I say that, from the smallest form factors of supporting a femtocell or an indoor small cell, just 16 to 32 users, to the macro scale, we support our software is elastically scalable across all these form factors and different deployment scenarios, be it indoor small cells, femtocells, or enterprise small cells, supporting higher number of UEs and throughput. And the outdoor small cells are the picocells supporting 256 users and beyond 2 Gbps kind of milestone. And some of these numbers we have benchmarked and made press releases. Example, the small cell FR2 millimeter wave solution, we made a press release announcement with Qualcomm last year. And another milestone was achieved this year when we crossed 1 Gbps in a FR1 implementation, again in a trial. And we are now focusing on making the tower bottom CU and DU ready in the CNF containerized form with 512 UE support at least, and showing a throughput of 6 Gbps, greater than 6 Gbps, supporting multi-cell combinations. And this is mainly focused on the FR1 or the sub-6 spectrum. So we see that our software is easily scalable and deployable on an edge cloud as a virtualized CU, virtualized DU, supporting multi-cell capabilities, multi-Gbps, and scaling in and out like a true cloud native software. This is what we've been designing in and focusing on. And our architecture inherently supports all types of split, option 2 split, option 6 split, option 7.2 ARP. And the focus on the vRAN will be on making sure we follow the industry standard container platforms and so on. Okay. And if we can go to the next slide, please. Yeah. This slide talks about our capabilities in the system integration. And we have been a specialist in doing optimization on different target platforms. So with that deep knowledge of optimization and benchmarking, we are a specialist in the RAN integration, RAN system integration. And we are also being backed by the expertise that is coming from our sister company, the group company, Reliance Jio as an operator, the best practices and the tools and technologies for doing the best of breed integration of multi-vendor solutions. We bring in those aspects as well to our customers to provide an end-to-end system integration experience, including the program management aspects. So we have been offering this as our additional capability in addition to the RAN products, the software offering, which we just talked about.
5 minutes.
Yeah, can you please go to the next slide? I'll try to. So in terms of evolution, we are already launching this by the end of the year with the virtualized DU and CU with public and private cloud support, mainly targeting eMBB. As the technology evolves in both 3GPP side and O-RAN side, we would be supporting advanced use cases. And here is where we see the opportunity to collaborate, innovate with the ecosystem partners. And John Baker said something about co-optation. That's also going to happen as we go into the next few years of Open RAN, how it is becoming predominant flavor of deployment. And we see the ecosystem wholly participating and Redis is playing a key role. And we also see this as the laying of the foundation of the networks towards 6G. When we reach 2024, the kind of capabilities we are going to have will lay the foundation, both in the network side and devices side, will lay the foundation for the networks to evolve into 6G. And that's our vision, to do all of this in a partnership mode with companies based out of US. And in this regard, our membership in NextG Alliance is where we see the opportunity to collaborate with the rest of the US-based companies to push and influence the 6G roadmap. Can you please go to the next slide? So in summary, this is what we are seeing as our USP. A lot of expertise built over the last 3 decades in building 3G, 4G, 5G protocol stacks and enabling multiple OEMs across the globe in different form factors and different types of deployments. That's our inherent strength, and all our solutions in the O-RAN space are software-centric and flexibly deployable across different hardware and private and public cloud platforms. And we see the opportunity to play into the private networks as well through our focus on software. And we have the widest possible ecosystem partnership. We follow a multi-platform strategy and with a focus on compliance to the open standards and open interface-based interoperability. And finally, with our deep system integration capabilities, being a deep RAN specialist, we see that we have the ability to bring the best experience of not only delivering the products, integrating them and making them deployment ready. And that's how we will be a compelling offering as a company, our Open RAN solution. And I would like to close up with playing the video, which is our software getting deployed in the Sonic Lab in UK, and that will be our closure. Thank you for the opportunity. Thanks for listening in.
One of the 3 Open RAN systems here in the Sonic Labs is a 2-vendor system integrated by Radisys in an end-to-end 5G network solution. The system is geographically distributed among 3 sites, namely Digital Catapult London, Brighton, and Ofcom Riverside House. The Network Operations Center, where our 5G core network is running, is hosted at Digital Catapult London. The Open RAN network elements are hosted in Brighton, and Ofcom Riverside House. The centralized and distributed units were developed by Radisys. The radio unit was developed by Foxconn. The Open RAN system is connected to one of our 4 5G core networks, and in this instance, we are using the Radisys 5G core network. Over which the BBC application you've just seen was running. The system is fully operational and allows us to investigate and test interoperability at different interfaces. Here we can see the different consoles of the fully operational end-to-end system. Here we can observe the radio unit latching onto the distributed unit. Here we can see the console of the PTP synchronization server. And here we can see the console of the distributed unit. Here we can see the console of the centralized unit. And here we can see the console for the 5G core network, particularly the user plane function. Here we see the traffic traces of the running system across the Open RAN components and the 5G core network interfaces. If we look here specifically, we can see that the user equipment has successfully connected to the Open RAN network, as evidenced by the PDU session resource setup response. Building this capability in the Sonic Labs has been truly insightful, both in terms of the integration steps and the challenges faced to get the system up and running. This process has highlighted several integration learnings along the way. For example, the need for cryptographic cards in order to support over-the-air authentication of user equipment, the need for FPGA accelerator cards in order to support larger bandwidths, the requirement for the allocation and assignment of specific CPU cores and NUMA nodes in order to run the C.
Thank you, Ganesh. And now we'll turn to Azita Arban, the General Manager of Rakuten Mobile Americas.
Hi, Brian. Thank you very much. And thank you to FCC for providing this opportunity. As Brian said, I'm Azita Arvani, General Manager of Rakuten Mobile Americas. And I'm here to talk about Rakuten Communications Platform. That's really, you can think of it as an easy button to bring 4G and 5G network based on Open RAN and virtualized RAN and cloud native end to end. And we are on the board of Open RAN Alliance, in addition to being on the board of Open RAN Policy Coalition, and we're working with TIP as well. So, and what we have is really a platform that first we use ourselves, and so that gives us the 360-degree view. My experience in 20 years of being in telecom has been, if you work with a vendor, which I have, you really very much focus on technology and how and providing the solution. If you work on the operator side, you're very much into making sure that this technology works in real world with the deployment issues. And for us, being able to be on both sides of this, being an operator, we see the deployment issues, and we have the platform that provides the right technologies for it. So if you go to the next slide, please. So we are a global company with different businesses. And 3 points here that are relevant to our conversation here is that the reason why we are set apart from other vendors in this Open RAN, virtualized RAN space is that we bring in this cloud DNA that has been with us for all of our businesses with telco talent together. And really the magic of virtualized Open RAN for us is at this intersection of these two different sets of talents. The other thing that's relevant to us is that, you know, when people think about Open RAN, they like the flexibility, but they're afraid of system integration, which would be more vendors that are involved. And there's this concern about there's no one throat to choke if something goes wrong. And so we're providing that one point of contact where provides that safety net, if you will, for operators to know that we'll be there making sure that this all works together. And then third relevant point here for our conversation is that when people talk about Open RAN, and they usually think about a lot of newer players, and there is this concern that these are some of these startups and they may go out of business. And here I wanted to show that we have a great balance sheet, we have great P&L, we are a strong company, and we are totally committed to Open RAN, providing the solution, so we create a stable foundation for carriers to be able to lean into the future. Next slide, please. So in an overall view, the way we look at architecture is really based on 4 strategic pillars. And this is important because you'll see it as I talk about the solution later. Number 1, about disaggregation of the radio. And for us, that disaggregation happens at 3 layers. So the first layer is to go from this proprietary stack of RAN into Open RAN, which, as you've seen throughout the last couple of days, is breaking it up into these 3 layers and having open interfaces between these layers. So we're the first one who have commercialized that Open RAN, and we truly believe in the power of that. But then the next level of disaggregation for us comes at this virtualizing these pieces. So instead of having proprietary hardware and software, we have virtualized software running on top of IT servers. So that really helps bring down the CapEx quite a lot. And then there's a third layer of disaggregation for us, which we really look at the radio unit itself, and we design it and build it with our partners in order to reduce the cost on that as well. So we look at it more like a white box and trying to optimize there as well. An example of that is the millimeter wave base station that we have designed and developed in partnership with Qualcomm and Airspan and Altiostar, and that that unit, our millimeter wave base station, is at this similar price point as a enterprise Wi-Fi access point. So that those 3 layers of disaggregation really gives us a lot of efficiency, a lot of flexibility, but also much lower cost. The next pillar of our strategy is on unified cloud. We believe that having one cloud that goes across different layer, having one underlying cloud that goes across different tiers of the cloud, it really helps a lot with bringing more elasticity and more automation and scalability to the system. At the same time, we understand that sometimes it's not possible to make that happen. So, so flexibility is needed there. So we are very open to and have products that we have delivered to our customers that run on various other clouds. When it comes to automation, we leverage the latest cloud and open technologies and agile methodologies to make sure that our platform is really not just multi-vendor, but even with the multi-vendor is able to not just stitch together a number of point solutions, but make it in a way that's very streamlined, and all these different network functions that are best of breed are orchestrated and managed in a way that is part of the holistic system and enables the automation. So we are very, very focused on moving that automation forward. We've seen massive benefits in our own network, and we bring that RCP, Rakuten Communications Platform layer, to other operators as well. And the last one, just to let you know that our organization is what we call a platform organization. So we don't have these silos of people that are experts in different parts of the network, but really having a platform group that looks at the entire system as a whole. So if you move to the next slide, please. Here's the structure of Rakuten Communications Platform, which is the engine behind what we offer in Japan as an operator and what we offer to other operators in the world. And we're hoping that we can work with you in as you are considering modernizing and operating your networks. So it's basically made up of 3 layers. At the underlying layer is the RCP cluster, as we call it, which is the state-of-the-art underlying cloud layer. It's distributed and efficient telco cloud layer. It's containerized, running on top of Kubernetes, but hardened for telco requirements. It's able to run both the radio workloads, which, as we all know, are very special and very special requirements in terms of latency and other requirements, and as well as the IT workloads. So this is really the pinnacle of what the industry has been talking about for a long time, how IT and network is coming together, and we're actually deploying it now and have deployed it for the last year and a half. Oh, sorry, if you can stay there for that, thank you. The next layer up is the network functions layer, and this is where we bring the best of breed of different vendors that are shining in those areas. And for example, in the VDU, VCU, which is our virtual baseband software, we have Altiostar that we have integrated into this network function. In terms of core, we're working with NEC, which we have those products ready now for 5G and 4G, 5G combos by January of next year, and also all kinds of other network functions, as you see here. And again, the beauty here is that this is not just a bunch of vendors put out there, but this is onboarded in a systematic way. We manage them in a systematic way. We monitor them and grab the logs and traces and so forth in a systematic way. So then when you go up to the 3rd layer, which what we call RCP Automator, or you can think of it as the next generation OSS, this is where we really bring a lot of automation and a lot of ease of management into running the network. We all know that as an operator, if you're not able to have a single pane of glass to all of your network, it creates that swivel chair type of management, which makes it much more difficult and time consuming. And also you have to have experts in various different vendors that you have. And what we are doing here is providing one point of visibility to all of your networks, regardless of which vendor is bringing that function to you. So, and if you can think of it as like the FCAPS functions, the fault management, performance management, we also have closed loop automation here. So a lot of the actions that need to be taken when things go wrong, the fault management, for example, they're done automatically. So you can make your operational staff much more productive. Coming back to the RCP cluster, our software layer of the cloud runs on top of 2 COTS hardware, which we have optimized for running this mobile network. The reason for making it into 2 is really to simplifying it, the infrastructure, because even if you run on top of COTS hardware, if you're not careful, things can get complicated in terms of ordering multiple flavors, and then gets more complicated with the ordering, logistics, warehousing, etc. So we have worked with ODMs to build the design that we have that makes it much more efficient and much lower cost point. So if you go to the next slide, please. I have covered this, but just to kind of make sure that there is clarity on this, full clarity on this, is that in Japan, we are a mobile operator, which we are the world's first and still the only fully virtualized cloud native network, both on 4G and 5G. And the platform that runs that is Rakuten Communications Platform, or RCP for short. And that's what we are offering to the US operators and other operators around the globe. So if you move to the next slide, please. Just to give you an example of how this RCP works in action, this is what the Rakuten mobile architecture looks like in Japan. So if you see, we have 3 tiers of cloud. These tiers can be collapsed together depending on the topology of the operator, or it can even extend beyond that as needed. And so on the edge data center, we are putting in the functions that need to be closer to the cell sites, such as the VDUs. If there is no fiber available to the site, then the VDU can actually reside on the site. So we have examples of that, for example, with our 5G millimeter wave. So we support both 7.2 split and split 2. Again, depending on the topology, we understand that every operator's environment is different. So these things have to be flexible to be able to meet those requirements. And then the other parts of the network, other network functions, can reside on the regional data centers, like you see here with the CU, the VCU, or also with the other functions like the UPF and the 5G core, and then the least real-time functions would reside on the centralized data centers. And on the regional data centers, we have worked in the separations of the control plane and the user planes from the beginning. So that means that if you are having sessions where you have a lot of throughput needs, so you can scale that independently than sessions that might just be lots of sensors in your network, or lots of users with smaller data traffic, but more of them. So you could scale on the control plane or on the user plane independently of each other. As you can see, this is an open
5-minute warning.
I'm sorry?
It was just a 5-minute warning.
5 minutes? Are you sure?
Yeah, sorry.
Okay, all right. So if you can then move to the next slide, please. This is how we have done it in our network with the initially with the 4G network on the left-hand side, moving the 5G NSA, the non-standalone, and then we have launched our 5G standalone, which we will be fully completing by Q2 of next year. So if you go to the next slide, please. This is we now have over 4 million subscribers. So, and as you can see that the Open RAN, virtualized RAN solution that we're talking about is not just something in a lab or a POC. This is scaled and it's serving over 4 million subscribers. So the next slide is, this is about the operations of the network. This is where we are seeing the benefits of automation in action. So I'll just make a comment about the second box from the left on the cell site deployment, that in our 4G, the cell site activation was under 10 minutes, 8.5 minutes to be exact. And in 5G, we have reduced that to 4 minutes. And this is versus like 3 to 5 days that normally people take to bring up a new cell site. So, and then also the other, the second box from the right talks about how our automation improves the operation staff's productivity. So instead of having one technician per 1,000 subscribers, we have one service reliability engineer for every 20,000 subscribers. So it's a 20x improvement there. In interest of time, I'll move over to the next slide, talking about how with Open RAN, we've really simplified the way the site is deployed. So as you can see on the left-hand side, there is a lot of hardware at the bottom of the tower that has the cabinets with the baseband unit and hardware in it. And in our case, on the right-hand side, that stuff has been virtualized and sitting in a data center, and it can not only support one cell site, but multiple cell sites, so you can pool the baseband functionality. So if you move to the next slide, I wanted to show you the, right, so these are moving from a traditional RAN, which all the interfaces are proprietary and it comes from one vendor, versus on the Open RAN, all of those are standardized and we can bring them from multiple vendors. And I'll show you an example of that later on. So next slide, I wanted to show you an actual picture of it so you can imagine what this looks like. And so this is an actual picture of our, what we call a concrete pole. So as you can see, it's only the radio units and antennas that are integrated sitting on top of the tower, and everything else in terms of baseband is offsite in a data center. And that helps a lot with when it comes to weatherizing. You don't need to do when it comes to scaling, and when it comes to being able to pool, but also like in areas where there is floods and things like that, this architecture makes it much more resilient. And for us, it has reduced the CapEx by 40%, and this whole architecture has reduced the OpEx by 30%. So our TCO numbers look very good. Of course, every operator's mileage will differ, but it'll be around the same neighborhood. So if you go to the next slide, this is sort of if you decide to do a legacy RAN architecture on the left-hand side, the entire RAN stack will come from one vendor. Here we call it vendor A, that gives you the baseband, different portions of it, and the radio unit, and these are all black boxes. And on the right-hand side is what you see, what we have implemented and is ready to to be delivered, which is you have the cloud infrastructure and the RCP automator on top, and then you have the different versions of 4G and 5G, and they can, they are all independently being innovated on, and you bring multiple vendors to support you on that. So next slide, I'll.
Sorry, Azita, I cut you off there, but as a reminder, all of the presentations will be posted on our website, and we'll also post your contact information so providers can reach out to you with any questions. But thank you very much. We appreciate your presentation.
Thank you.
And our last presentation for session 6 is from Alok Shah, the VP of Strategy and Business Development and Marketing at Samsung. Alok, I'll throw it over to you.
Thanks very much. Hi, everyone. And thank you to the FCC for hosting this event and giving us the opportunity to participate. My name is Alok Shah. I support strategy, business development, and marketing for Samsung's US networks business. Next slide, please. So I'll start by introducing Samsung Networks, then talk a little bit about our experience in ORAN and vRAN with operators, which we think is quite substantial, and our contributions to the broader ecosystem, which we also think is quite substantial. We'll touch on the opportunities and challenges involved, and then finally, we'll talk about Samsung's product and services portfolio to help operators navigate through those challenges. Next slide, please. So I think everyone on the call is familiar with Samsung. We're the #1 provider across a range of different product categories that are widely loved by consumers and businesses. Samsung employs 20,000 people in the United States. We've invested over $30 billion here, and recently announced an additional $17 billion investment in the US centered around chip manufacturing. We actually manufacture 5G chips, both for ourselves, one of our modem chips, and other customers at our facility in Austin, Texas. In the bottom left of this slide are a couple of examples of our networks products. You may not be quite as familiar with Samsung Networks as other parts of our portfolio, and so now I'll pivot over to focus on that business. Next slide, please. Samsung has been in the networks business for about 40 years in the US and in leading markets around the world. We work closely with our customers, who are primarily service providers, across a broad portfolio from RAN to core that includes tools, analytics, and services. We'll get into that portfolio in a little more detail later, so let's go on to the next slide, please. Samsung, as I said earlier, is a leader in ORAN trials and commercialization, and I'd like to walk through a few examples of that work with leading operators. I'll start in Japan, which has been, as Azita noted, a hotbed of ORAN activity. We're proud to have been selected by both KDDI and NTT Docomo to supply ORAN compliant solutions. Docomo is actually a new customer for Samsung Networks, and one of the instances where there are multiple suppliers working together in the commercial 5G network. Samsung is supplying a portion of the Open RAN, and other suppliers are bringing in other portions, so true multi-vendor integration at work. In Europe, Vodafone recently announced Samsung is a major partner in the first large-scale Open RAN deployment in the continent. And while we're focusing on Open RAN today, Vodafone is actually deploying a virtualized RAN architecture as well. vRAN sits alongside ORAN as an important architectural advancement for operators, and it's another area where Samsung has taken a very strong leadership position. We actually generally separate ORAN and vRAN in the way that our operator customers these next generation architectures. In some cases, operators decide to lead with ORAN. In some cases, they decide to lead with vRAN. In other cases, they decide to do both at once. Samsung, for Vodafone, Samsung is providing virtualized DU and CU software, as well as massive MIMO radios and traditional radio units as part of the overall 4G and 5G deployment. And last but certainly not least, we've been working closely with customers in the US. In fact, back in 2018, before the ORAN Alliance even existed, Samsung was a part of Verizon's Open RAN program, which involved a heavy dose of multi-vendor integration. it was a program where Samsung came in and interoperated with incumbent vendors in that 4G network. That program actually evolved into an expanded partnership with Verizon that now includes a fully virtualized commercial 5G RAN that is in production. Samsung and AT&T have worked closely on O-RAN projects over the past few years. In the case that's cited here, it was actually around millimeter wave spectrum. Samsung has been investing in millimeter wave for quite a long time and feel that that's a strong area of leadership for us as well. Next slide, please. In parallel with our customer engagements, Samsung is an active contributor to a number of industry groups that are advancing various aspects of the O-RAN standards. This is an extension of our work at organizations like 3GPP that drive the overall direction of innovation in our industry. O-RAN Alliance in particular, as many folks have spoken about over the last 2 days, is central to establishing the specifications that are needed to move toward commercialization, and Samsung has taken a very active role in a number of different working groups in the O-RAN Alliance and contributed quite a lot of content. What is interesting and really great about these organizations here is that they all feature the active participation of operators. And those operators ensure that the output of these groups aligns with their needs. In the past, we've had other attempts to define open interfaces within the RAN, but ultimately they were never really truly open, in large part because the direction of those specifications was left almost entirely in the hands of vendors. And so the fact that that's not the case now, that a number of operators are taking very active roles, I think can give us as a broader ecosystem confidence in the ultimate success of Open RAN. Next slide, please. As a company that's worked closely with customers and the broader ecosystem on commercialization of O-RAN, we feel that we have enough credibility to say that there are clearly benefits, and we can talk about those, but nothing in life comes for free either. There are clearly positives for operators, driving more competition into the RAN, being able to select best-in-class vendors, being able to quickly make changes to the network as needed, roll out new features, all of those things, especially when you layer on the potential advantages of vRAN as well, bring tremendous benefit to operators. But when you do have multiple vendors, that means multiple hardware, multiple software, multiple firmware releases that come at different times and have to be carefully tested on an ongoing basis. Either the operator has to take on that responsibility in-house, which some of the larger operators have signed up to handle and are capable of handling, or you have to have a really capable and trusted system integration partner in place. That's an area we'll talk about more, and we do see a really interesting group of system integrators stepping up to help operators navigate that journey. Next slide, please. Samsung offers a broad portfolio of 5G RAN products. Maybe we shouldn't go through all of it, but we go from low and mid-band spectrum all the way up to millimeter wave. On low and mid-band, generally, we have both traditional radio solutions, 4T, 4R, 2T, 2R type, and massive MIMO variants. We'll come back to the massive MIMO topic in a second. On the baseband side, we have both purpose-built baseband units as well as the vRAN architecture that we were describing earlier, where our software is sitting on top of general-purpose computing platforms. Millimeter wave, I want to talk to you just for a second. That's an area, like I said, where Samsung has been quite innovative and technologically advanced. There's a product there in the middle that we call the Compact Macro. That's actually an integrated antenna, radio, and baseband unit that we think provides meaningful advantages around ease of installation and deployment, as well as both as size and power that we think is quite meaningful. On the MIMO side, on massive MIMO, one of the challenges with vRAN especially has been how to support not just low band spectrum, but mid band spectrum, which tends to be wider, and especially massive MIMO. And Samsung has now commercially deployed massive MIMO radios with our vRAN in networks, commercial networks, and feel quite confident that we've been able to establish that capability. Another point that I think is quite important here is the importance of Samsung's chip development. We offer not just network equipment and mobile devices, of course, but we develop many of the chips, the key computing chips and RF chips that go into many of our products. So the compact macro millimeter wave radio that I talked about features Samsung RF and modem chips. Our massive MIMO radios include beamforming, silicon or system on chip solutions that provide a huge performance boost and still allow the ability to operate these flexible next generation systems. I want to be clear that not all of the products here are O-RAN capable today. Some of them are, and O-RAN support in our portfolio is growing pretty rapidly. So I'd like to encourage folks to reach out to us to get into the details of our specific products that meet your specific needs. Right, this is very much a solution set where we have to look at the requirements of each operator. So happy to get into that discussion. Next slide, please. Thank you. As I noted earlier, a trusted and capable services partner is really critical in the efforts of designing these next generation network architectures. And then ultimately supporting the ongoing testing, optimization, and support that's required. And there are a group of companies that are, I think, beginning to develop expertise in this area. One that I'd like to call out is a company called Teleworld Solutions. It's a wholly owned subsidiary of Samsung. We acquired the company in early 2020. And TWS is really quite capable of supporting operators as they go through this journey. They've got over a decade of experience in professional services, working very closely with Samsung and with a range of other customers today in really all aspects of this services lifecycle. Design of in-building systems, of macro systems, various technologies across that, deployment, all aspects of deployment and installation. Testing is a core strength, optimization, management support, new business models perhaps like hosting and managed services, and then even moving toward the IT side of the house, and both virtualized platforms, multi-access edge computing systems. So TWS has really a broad set of capabilities, and I'll note that their expertise is not limited to Samsung products. Right, they had a long life prior to Samsung and continue to support operators with the full portfolio of products that those operators have deployed. So in closing, why is Samsung the right partner for operators as they move to 5G and new architectures? So first, we've been in the US for 40 years. We've made very, very large investments here and offer a secure and trusted supply chain to our customers. I think the ability to be in this for the long haul is very important, and it's a long slug, right? There's always a G that comes after the current one, and so it's important to choose partners that will be there with you. Second, we're invested in technology. We're actually one of the largest R&D spenders in the world, bar none. and we develop, like I said, market-leading 5G products from chips to devices to networks and beyond that, right? I like to say that the future of the network architecture is ultimately chips and software, and I think you've seen that from various presentations over the last 2 days, and we feel that chips especially are hard to build, right? Samsung happens to be one of the largest semiconductor companies in the world, and it's an expensive investment. It requires a lot of expertise, but brings a tremendous amount of value when it comes to the performance of the network. Third, O-RAN and vRAN, we come from a place of strength. We've made a big commitment, especially as a challenger in the market, to bring market-leading solutions, to bring the types of solutions that our operator customers are looking for. And we have a number of wins around the world to show for that. Fourth, competitive product and services portfolio. And then finally, the pace of technology continues. We started our 5G R&D back in 2009. We started our 6G research last fall. And you can be confident that Samsung will continue to invest in technology leadership for many decades to come. Thanks very much for your time and attention.
Thank you, Alok, and thanks to everybody who participated today. That concludes section 6. I just want to send a general thank you to all of the vendors who participated in the FCC's Open RAN Showcase. For some closing remarks, please allow me to reintroduce, Justin Falk, the Acting Associate Bureau Chief of the Wireline Competition Bureau. Justin.
Thank you so much, Brian. This has been a fantastic 2-day showcase featuring a number of compelling vendor options. And with Acting Chairwoman Rosenworcel just recently announcing that the Secure and Trusted Communications Network's reimbursement window target to open is October 29th. I hope that a number of the vendors providing have piqued the interest of some of the providers who will be participating in the reimbursement program, and that those 2 parties can connect offline. We've heard so much useful information over these last 2 days that I do think it's valuable to provide a few general kind of themes as we leave this showcase. First, O-RAN equipment and services are available today. And there's a diverse ecosystem of high quality vendors that are able to fit providers' needs. And that should be they should be reaching out to try to figure out exactly how they can create the unique partnership that they would need to reach the provider's customers. Second, these vendors take network security seriously. We've heard from a number of our vendors the importance of network security and how these O-RAN solutions can protect both the network and consumers, and something that will continue to play into all the development that goes forward on O-RAN and future communications networks. Last, everyone on the showcase has agreed the future is bright. O-RAN and some of these related technologies are forever going to change networks, and now may be the time to get in if it's your provider's plan. For providers who are interested in following up with the vendors that we've heard over the last 2 days, we're going to publish their contact information on the FCC's webpage, specifically at the events webpage for the showcase. You can find that if you aren't there now at fcc.gov/events. Importantly, I want to take a moment to recognize a few people who made this event happen. First, the Wireless Telecommunications Bureau's Connor Kane and Cecilia Solhoff were fantastic, and this event could not have happened without their dedication and hard work. Also, like all FCC events, we need to thank, and we owe a gratitude to the commission meeting room staff, specifically Jeff Riordan, Greg Huff, and Stephen Balderson, because they make these things happen, and they make them run on time, and they make it look great. And so we should all take a second to thank them. Lastly, I'd like to thank Acting Chairwoman Rosenworcel for her leadership on these issues, and our distinguished speakers from the National Security Council, NTIA, and our fellow FCC commissioners. Thanks to everyone who's participated and pulled together presentations to share with providers. And thanks to everyone who watched and hopefully took some notes and learned something. I hope you all have a great rest of the day and look forward to speaking more about these topics in the future. Thank you.